right, hello guys. I hope you guys are well. Hope you guys are well. Grade 10, paper 2. Great. Yeah, but with a primary focus, guys, on what? On two things: analytical and trig. Just analytical and trig. All right, no Euclidean, just analytical and trig. Heavy focus on that. Okay, so the live is now starting, which is at 9:16. We will end at 12. So this is going to be quite a long live lesson. Okay, what's the intention? It is to prep for those that are still in preparation mode for analytical and trig paper 2, grade 10 though, no other grade 10 guys, and just grade 10. Okay, so we're gonna start very nice and slow, and I have my live goal up there. So if there's any generous people that are feeling like they want to live goal me up, you can contribute to my live goal, guys. It is there for the taking. All right, it's there for the taking. I hope those that have been writing or have written, who have been part of my live lessons, can actually share what it has been like to write their respective exams. That would be nice. Okay, so let's go. Let's get this party started. All right, and we are gonna get it started up with a few questions here, and I hope you guys can have this checked out. There we have it in the diagram below. So this is a Nelson Mandela Metro paper, all right, written in 2025. Okay, so let's look at it in the diagram below. A minus 2ab, b minus 9, c 4 and minus 3 are vertices of an isosceles triangle ABC in the Cartesian plane m minus 3 and in -2. M minus 3 and -2 is the midpoint of AB. So if you're looking at AB here, m minus 3 and minus 2 is the midpoint of AB. And we are told that AC is equal to BC. All right. So once again, in the diagram below, just check it one more time. It says A minus 2 and A, B and minus 9, C, 4 and -3 are what? Are vertices of isosceles triangle. Isosceles triangle who? Triangle ABC. Then we are told in the Cartesian plane, then M, which is -3 and -2, is the midpoint of what? Of AB. And AC is equal to BC, which further shows indeed that this is an isosceles triangle. So let's come down here. The first question says, show that the values of A is equal to 5 and B is equal to -4. Show that the values of A is equal to 5 and B is equal to -4. All right, so A, we need to show is equal to -5, is equal to 5. A is equal to 5. Now guys, if you look at A being 5 on the second quadrant, all right, does it make sense that it would be +5? Yes, it does, because it's in the second quadrant. Y is positive in this quadrant. B is equal to -4. We need to show that B is equal to -4. Would it make sense that B is equal to -4? Yes. All right, because remember, that's on the x-axis. X values are negative, and obviously the midpoint x coordinate is -3. So the fact that the next x value after that, before that, would be -4 would make sense. But we need to show that the values of a is equal to 5 and b is equal to -4 for how many marks? For 4 marks. So the question then is, what do we do to show that the values of a is equal to 5 and b is equal to -4? Well, we are told that m is a what? Is the midpoint of who? Of AB. So we want to find the y coordinate, which is a, and it's the y coordinate of a particular endpoint. All right. So AB are the end points of this midpoint. And usually when you want to find the midpoint, you usually take the coordinates of the endpoint for x and y respectively. You add them and then you divide by 2 to get the midpoint. But this time round, you have the coordinates of the midpoint. And more specifically, if you want the y coordinate, right, of the midpoint, what would you do? You would actually take the y coordinate of the endpoints, add them together and divide by 2. Okay. So yeah, go ahead, Shiz Chubby. You want to take this for practice? There we go. Take the screenshot. Take it. Here it is. Can you see it? Is it visible enough? There it is. Okay, grade 10, guys, grade 10. This is grade 10. All right, hope you saw. No, all 4 is like no, what? Why are you saying no? All 4, all 4. Okay, so if we want to get this y coordinate, all right, what we are going to say is we are going to say the x coordinate of the midpoint. The y coordinate of the midpoint, because remember, we want a. So what we are going to say is 2.1 y coordinate of the midpoint is equal to, okay, all right, let's just look at this again. Y coordinate of the midpoint is equal to the y coordinate of a, which is one of the endpoints, plus the y coordinate of b, which is the other endpoint, and we will divide all of that by 2. Now the y coordinate of the midpoint is -2. We substitute that. The y coordinate of a is going to be substituted with the a that we have there, plus the y coordinate of b is -9 over 2. Does that make sense, guys? Are we moving together? We want a, which is a endpoint. It's the y coordinate, all right? A, small letter a, is the y coordinate of a. But I have the midpoint, which is -2, and I have one of the other endpoints, which is the y coordinate of b. So in order to get the y coordinate of the capital letter A, I'm going to say the y coordinate of the midpoint, which is m, would be equal to the y coordinate of A, which is one of the endpoints, plus the y coordinate of who? The y coordinate of B, which is -9, all over 2. So what I have now is an equation where A, small letter a, is an unknown. So what do I do here? I know that this is an equation. I have a denominator on one of my fractions. So what I'm going to do is I'm going to cross multiply. Or I could say the LCD for this equation is 2. So then what I do is I multiply each of my terms by the LCD. which is basically why I say the shortcut is cross multiplication. Because if I multiply by 2 here in the numerator, the 2 and the 2 cancel, multiply by 2 that side, 2 times negative 2 is equal to a plus negative 9. Okay, a plus negative 9. Positive times the negative, so that's negative 4 is equal to a minus 9. Because the positive times the negative is negative. Take the negative 9 over, negative 4 plus 9 is equal to a minus 4 plus 9 gives me 5. Therefore, a is equal to 5. So I think I've just shown the very first of my problems that it is actually equal to 5. A, small letter a, is equal to 5. Okay, did we see how we did that, guys? Okay, as I'm saying again, the y coordinate of m, which is negative 2, would be equal to the y coordinate of a plus the y coordinate of b. That's how you get the midpoint. You take the coordinates of the endpoints, add them together, and divide by 2. There we have it. Y coordinate of a plus y coordinate of b gives us the y coordinate of the midpoint. Okay, right. Then what do we do? Cross multiply. 2 times negative 2, negative 4. A plus minus 9, positive times the negative is a negative, negative 9. Then I take the negative 9 over, negative 4 plus 9 gives me positive 5. So a is equal to 5. And that's how I get a is equal to 5. Let's do let's do the second part of 2.1, which is to get the b, show that b is equal to negative 4. So here we have another endpoint, but it's the x coordinate of b this time around. But in order to get this, I'm going to have to say the x coordinate of m. The x coordinate of m is equal to the x coordinate of b plus the x coordinate of a divided by 2. So let's do that again. X coordinate of m is equal to x coordinate of a plus the x coordinate of b divided by 2. What is the x coordinate of m? Negative 3. What is the x coordinate of a? Negative 2. What is the x coordinate of b? Small letter b over 2. Then what do we do when we are here? Play the cross multiply game. So take the 2 cross multiply it, or we would say find the LCD. It's 2, you multiply by that LCD in the numerator, left and right. When you multiply by 2 here in the numerator, the 2 and the 2 cancel. Multiply the negative 3 times 2. Obviously that gives me something. Negative 6 is equal to negative 2 plus b. Take the negative 2 over, you transpose, isolate the b. B is equal to negative 4. All right, so there we have it. I think we've just shown both of the values, that a is equal to 5 whilst b is equal to negative 4. So for 2.1, guys, all right, very evidently we are getting the x and the y coordinate of the end point when given the midpoint. All right, and all we do here is set up the equations using the midpoint formula. When you have the midpoint and you want to find the endpoints, then you need to set up an equation. Okay, so I hope so hopefully that helps us out a lot. All right, okay, move on to the next question. 2.2, calculate the length of AB. Right, calculate the length of AB, and it says leave your answer in simplest surd form. So in analytical geometry, when we are asked to calculate the length of something and leave our answer in simplest surd form, that means we leave our answer in an irrational form state. meaning we are going to leave our answer having a root or a root in it, and in the most simplest state possible. So AB, all right, notation wise, we can say AB, and then we draw a very long square root. We say the x coordinate of A minus the x coordinate of B, the whole thing squared, plus the y coordinate of A minus the y coordinate of B, the whole thing squared. That way we set up, and let's identify the coordinates. We have -2 and what? Remember that A value was 5. That is our A, and then we have B, which is -4 and -9. So what are we supposed to do now here? Calculate the length of who? Of AB. AB, which is a what? AB, which is a side of a triangle. All right. So x coordinate of A, let's substitute that in brackets, -2 minus x coordinate of B minus. Okay, look at how our brackets are placed so that we can avoid confusion. Since there's a negative, of course that sorts out that we have to resolve the sign there, and then the square on the outside, plus y coordinate of A, that is 5 minus -9. Okay, be very careful there, guys. Okay, then very quickly, yeah, Mo, very good, nice. Must be nice to finish. Some people are still writing, unlike Diwena or Difetsi 5 plus 9. The thing is, yeah, some people are still writing, eh? Yeah. But remember, hopefully you understand the work. You know, it's one thing to finish writing, okay? Some people finish writing and they have no cooking clue what it is they wrote. They don't even understand the mathematics. You know what? It comes back when to bite you? In November, when you write your final exams. Because will you see analytical geometry again in term 3? Nope. But will you see analytical geometry in the final exam? Yes. And at that time, will you remember everything to it? Well, I guess that depends, according to the retention of information that you decide to keep. -2 plus 4, guys, is 2. So we have 2 squared. 5 plus 4, that gives us 14 squared. Okay. So we can then finish off. Okay, so we have 4 plus 196. That gives us 200. Is that so? And then we have 2. Actually, what's the simplified state of 200? Simplified third state. What is it, guys? Come on, someone, calculator. Because they said leave your answer in simplest third form. We don't want to leave it rounded off. We need to leave it in simplest third form. So what is the square root of 200? Or is that as simplified as 200 can be? No, it's not doing it. Definitely not doing it. Come on, guys. Square root of 200. Okay, then root 2. And then you write units. Okay, why are we writing units? Because remember the question said, calculate the length of AB, leave your answer in simplest third form. This is what they mean. Okay, this is what they mean. Then root 2, don't forget units. Okay, so that's the length of AB. So we've just answered now 2.1 and 2.2. 2.1, we show that the values of A is equal to 5 and B is equal to -4. This question required our midpoint application. Okay, formula of the midpoint where we set up two equations. How so? We are given, we want A, which is the y-coordinate of the line AB. We have the y-coordinate of the midpoint. We have the y-coordinate of the other endpoint. So typically when we wanted to find the midpoint, what would we do? We would say A plus, we would add the two y values and divide by 2 to get this y-coordinate. So we set up an equation in that fashion, but of course we have the y-coordinate of M. So we say y-coordinate of M is equal to the y-coordinate of A, which is A, plus y-coordinate of B, which is -9/2. And we cross multiply, we solve the equation, we get the A value. Likewise, we want B, which is an x-coordinate of one of the endpoints. The other x-coordinate of the endpoint is given. We have also the x-coordinate of the midpoint, it's given. So it means we can add these two guys. Divide by 2 to get this value. So x-coordinate of M is equal to x-coordinate of A plus the x-coordinate of B divided by 2. We substitute, solve the equation, cross multiply, we transpose, we get a B value of -4. 2.2 required us to find the length of AB. So we just did so using the distance formula. Why are you not punching it in the first step so that others may not be confused? What do you mean, why am I not punching it in the first step so that others may not be confused? kamani@gmail.com. I think your comment does not in any way help with anything, to be honest, Kamani, because your question is, why are you not punching it in that first step so that others may not be confused? What do you mean? The whole point is for clarity, okay? The fact that I have done this is for clarity, okay? For someone who does not know what distance formula is, they know that the distance formula here it is, all right? Whether you choose to use the letters of the actual points or use numbers, because I know some of you use x2 minus x1, y2 minus y1, that's fine. I mean, that's the same thing. You then substitute. You have to substitute, of course. I don't have the luxury of having a calculator, so I thought, you know what, let me just show you step by step with the bracket, you know, the sign resolved, the bracket, the sign resolved, the actual addition of the numbers to get 2 squared is 4, actual numbers 14 squared is 196, and then getting 200, and then ultimately being able to express that in simplified surd form. Okay, so yeah, this is in no way confusing, rather than it is explanation for someone even who does not, or who may have not grasped analytical geometry at school to begin with. So I always get baffled when people give comments like that, you know. It's not seeking clarity, seeking questions, and just someone commenting just like that. It doesn't make any sense. 2.3, show with calculations that CM, so say we had a line there, is perpendicular to AB. How do we prove that lines are perpendicular? Specifically here, we are asked to prove that CM is perpendicular to AB. So how do we do that? Okay, that's the million-dollar question. How does one prove that lines are perpendicular? I think Lucy wants to answer that question. The minute I asked, he requested. Hopefully she can speak. Hello. Hello. How are you?
Can you talk Zulu?
I can't speak Zulu because I've got a variety of people who are on the live that are from different language speaking backgrounds. So I'm just trying to hit a common ground. Yeah.
to understand Zulu because I'm in Zulu.
You understand Zulu? Are you in grade 10? Yes, I understand Zulu.
No, me. Oh, yeah, that's it.
You
Can you please repeat the question for me?
this one, 2.3.
3.
Yeah, says show with calculations that CM is perpendicular to AB. Yeah. C is there, M is here, and then AB is there.
That means that the gradient, when it times them, you must give you negative.
Beautiful. So when you times the gradients, they must give you -1. So how do I go about then proving?
Sorry?
Yeah, I hear what you are saying, but so practically, how would we go about proving?
Gradient of AB times
Okay,
gradient of CM.
so gradient of AB. So I need to find the gradient of AB first. All right. Let's find that gradient of AB. I think we have our points there. A and B we are given there. A is -2 and 5. B is -4 and -9. So let's go and find the gradient of AB. Y coordinate of A minus the y coordinate of B at the top. X coordinate of A minus the x coordinate of B at the bottom. So the y coordinate of A is 5 minus y coordinate of B. So there's another -9. We put it in brackets, minus. X coordinate of A, -2 there. Minus in the formula is already there. X coordinate of B, we have -4. So we put the brackets again so that the -4 is secure. Then the signs there next to each other multiplied.
Plus.
Exactly. Thank you so much. Thank you so much. And then at the bottom there,
Become positive again.
beautiful. So -2 plus 4. Then as we conclude,
4.
okay, 14 divided by 2 gives us a 7 there. So that's the gradient of AB. Now we need to find the gradient of the other line segment, CM. So C is there, coordinates of C we are given 4 and -3. M we are given is -3 and -2. So C, 4 and -3. M, -3 and -2. Okay, then we can go ahead there and calculate the gradient of CM using the same formula, just with those letters. Y, C minus YM, XC minus XM. So the y coordinate of C, we have -3, minus the y coordinate of M, -2, over the x coordinate of C is 4, minus the x coordinate of M, -3 in brackets.
Let me check it back in English.
Yeah, I can see my guy. Hey, it's doing the things. There's even that's funny sound there. Hey. Okay, minus 3 plus 2, 4 plus 3. We get a negative 1 over 7. So that is the gradient of CM, the gradient of AB. Then get what? The only thing that's left for us to do now, we have the gradients. So we simply take them and we multiply them as they are, because we want to check, when we multiply them, what is the resulting product of the multiplication of the two gradients. So 7 times negative 1, it does give us what? Negative 1, as you have said. Therefore, we can then conclude and say, yeah, that AB is truly perpendicular to who? To CM. And that's a beautiful conclusion to make, because we've made it on the basis of the product of the gradients giving us negative 1. So, yeah, that was a very good one, Misty. Yeah. So just for those who are listening, yeah, guys, please, it's very important that when we are doing questions related to calculating whether lines are perpendicular, we need to check the gradient of those particular line segments if the product will give us negative 1. So it's important to calculate the gradients individually first, establish what they are. Then you can take those gradients and multiply them to check, do you get negative 1? If you do, the lines are perpendicular. If you don't, all right, double check that you actually put the numbers properly in your substitution, because sometimes it happens that people do not substitute the correct numbers properly in the right place. Then it results in answers that are not supposed to be. So always just double check that you wrote down the coordinates correctly, you did not miss out any signs and all of that. But if you've done everything 100% correct and you get negative 1 with the multiplication of the gradients, then you can conclude the lines are perpendicular. But if it so happens, for some odd reason, that the multiplication of the two gradients calculated correctly do not give you negative 1, then that can only mean one thing, that the lines are not perpendicular. Right? So, yeah, that was very well done by my guy there in the comment section.
Who is clapping the hands?
Sorry?
Who is clapping the hands?
Yeah, hey, it's the audience, my guy. They are seeing the wonderful work you're doing. Yeah, it's the audience. It's like they're watching very keenly, you know.
Okay, let's proceed.
Let us proceed. All right, the next question, 2.4, says determine the coordinates of a point D such that the quadrilateral ADCM is a rectangle. Okay, so for those that were asking about
So
the
in
question
this case,
earlier,
it means we have.
yeah,
So in this case,
go
it
ahead.
means we have a new point.
Amen, my guy, that's very true. It means we have
two
a new
unknowns,
point.
X and Y.
Yes, that's very true.
This one will be a little bit longer.
It will be a little bit what?
Longer, but it's simple. But it will be a little bit longer.
Yeah. Yeah, and you can see, even look at the mark allocation is 2 marks.
So Max, oh,
Yeah.
this one needs you to work smart, not hard.
That's true. It does. It needs you to work very smart. Yeah, not hard. Yeah, that's very true. Yeah. So even there's this thing about orientation and the sort of like the labeling of the actually letters for the quadrilateral, which is a rectangle. Because if you look at the way that they've labeled it, they say ADCM. Now, that would suggest that we are going in a clockwise direction because the A is here. The D is supposedly, obviously, going to be here somewhere. ADCM. So it's like, ADCM. Kinda. You see? So there's this point somewhere here. But of course, like I said, we are going in a clockwise direction. I think I lost my guy there. Network issues. Doing the things, taking him down there. Yeah. I saw a familiar face actually here, passing by. Okay, let's do this. Please bring me back. It's network. Yeah, I can see network is doing a number on you, Mister. It's not merciful on you, the network. Join 2 times in 7 days. You don't mess around, do you? Hello, is it Lifa and Asenati? Okay, let's bring you back, my guy. See, I think we have you there. Okay, there we have you. You back, ne?
Yeah,
Yeah. I see. The network is doing you numbers there. Yeah. So
you still waiting for 24.
no, for sure, all the way, my guy. You seem like you wanted to spin kick this one, so I don't want to take the cloud from you.
I'm still thinking of an easy way to solve this because it's too much. I don't want to work hard. This one I'm thinking, it's too much. But I'm sure we're gonna use the coordinate of BC. The problem is we don't have the x-intercept of.
So I'm going to rough
Let's say
sketch
the
this.
thing.
Yeah, I'm gonna rough sketch this for you. The m, which is negative, so m is equal to is -3 and -2. So it would be something like this, ne? You have your a here, we already have the coordinates -2 and 5, right? You have your M here, which is -3 and -2. And then D would be like this mystery point that is here. Hence, I was speaking about orientation there and saying the way you would read this is ADCM. So like this is kind of like obviously a rough sketch, you know, so that we can at least get an idea of what we are talking about insofar as the quadrilateral is concerned, because they're saying determine the coordinates of a point D such that, and the such that part is that the quadrilateral ADCM is a rectangle. So the letter order is of importance because it kind of leads us as to roughly where we can anticipate this point to be. Okay, yeah. So hence I was saying that if that is the CM, then the AD, you know, you're kind of anticipating this to be here. And the way in which they label the order of the letters is such that you can actually say ADCM. So the rectangle is sort of like formed in that fashion. And so I just want to say, by inspection, you can find point D. How so? So I just want to sort of like help us in the thinking process, okay? If you look at the x coordinate of A and M, all right? The x coordinate of A and M. Whatever happened to this x coordinate to get that one, right, is the same thing you would do to this x coordinate to get that one. Okay. So for instance, -3, if you look at the x coordinate of M, what would you add or subtract to this x coordinate to get that one? -3 plus what gives you -1, or -3 minus what gives you -2? -3 plus what gives you -2, or is it -3 minus what gives you -2? All right, that's my question. What would we do to this x coordinate of -3 to get that x coordinate? Okay, if you have -3 and you want an outcome of -2 at the end, what do you do to -3? Thank you. What is it? FUCK. Oh my goodness, is that like another way of just using a swear word? What is this? Yoke? Fufu? No. Do you remember this is -3? That's -2. If you say add 5, Karabo, you're 100% correct. And FUOK. Oh, it's X. Yes. What do we do to -3 to get -2? Khotatso. Okay, thank you so much for that. Because I was like, yo, that word. I was like, what the? Okay, you thought why, Fufu? No problem. Okay, we've clarified that. So what you do to M to get A, the x coordinate of A, is you add 1. All right? Yeah. Then the question then is, so in other words, and then what do we do to Y? What do we do to Y to get the Y coordinate of A? Exactly, Fufu. Yo, Fufu, you are 100% there. Okay. So -2, we add 7 to get the A coordinate. Okay. Yeah. So A then would be -2 and 5. Yeah. So that's what we do to M to get A. Now, If we are moving in this direction, then for C, we can move in the same direction. So what are we going to do then to the C, the x coordinate of C? If we added 1 to the x coordinate of M, then we need to add 1 to the x coordinate of C. Okay, so that would mean 4 plus 1. What does the x coordinate of D become when we add 1 as well to the x coordinate of C? That becomes exactly 5, right? Then we do the same thing with the y coordinate. Negative 3, we add 7. What does that then give us as far as the y coordinate of D? We add 7. No, definitely not 10. Okay, negative 3 plus 7. Guys, please be mindful. Christ indeed is king. Thank you, dude. Negative 3 plus 7 is what? Is 4. Okay, so this is what we mean by inspection. This method here would apply to all types of palms. Okay, all types of what? Of palms. Now, in quadrilaterals, guys, we have these as being types of palms. Obviously, your parallelogram is a straight up palm. 2, your square is a type of palm. 3, your rhombus is a type of palm. And then 4, your rectangle is a type of palm. So being able to get your third point of a particular quadrilateral using this method that you see here, by inspection, okay, would apply to your types of palms. Why? Why does it apply? It's because all palms, all types of palms have this common property, and that is opposite sides are equal. That is why this method works. Opposite sides, both pairs of opposite sides are what? Are equal. That is why this method works here. So guys, this question is a very famous question. Determine the coordinates of a point D such that the quadrilateral ADCM is a rectangle. Now, D is a newly introduced point, but they are telling you that determine the coordinates of this newly introduced point such that, and look at the orientation and the order of the letters for the quadrilateral ADCM. So as I said to you, you say A and moving in a clockwise direction. AD, you're expecting D to be here somewhere. CM, because your rectangle, you also anticipate that your rectangle is going to be a type of parallelogram. Of course, this type of parallelogram exhibits this important property of opposite sides. Both pairs of opposite sides are equal. Hence, I said to you guys that you can use then this idea. Look now. Come back. Joys of being loved. Did I solve this right? My goodness. Okay. All right. Yeah. Okay, so determine the coordinates of a point D such that the quadrilateral ADCM is a rectangle. Hopefully, guys, we get this point. All right. So, did you see the method? I said you check with the given side. Because you know AM is equal to DC. What you do is you simply check the what? You check what happened to this x coordinate to get that one. Or you could have done it vice versa. You could have asked what happened to... The reason why I asked what happened to this one to get that one, it's because I'm wanting to get this coordinate. So it's of importance to me to know what happened to this x coordinate to get that one. So we found out that -3, to get -2, we add 1. Okay? -3, to get -2, we add 1. Okay? Then -2, to get 5, we add 7. Mr. Skelem, I'm good. Then whatever then we did for M to get to A is the same thing we would do from C to get to D. Or we could do it another way. Because we know this side is also equal to that side, whatever happened to the x coordinate of M here to get to 4, okay, is the same thing can do to the y coordinate of M to get to the y coordinate of C. Does that make sense, guys? The x coordinate of M, what did we do to get to 4? So you could do the same thing. -3 plus what will give us 4? That's the question. -3 plus what will give us 4? Okay, because we could do it that way as well. -3 plus what gives us 4? Okay, I'm sure you can see, guys, that -3 plus what will give us 4? -3 plus what will give us +4? Does anyone know in the comment section? -3. Yes, Mr. Skellem, we know that. It's just that we are trying to look at this method because you see, for the 2 marks that we are asked here, this one, it really does the things. Yes, Karabo, very good. -3 plus 7 will give us 4. Very good, Karabo. Very good, Karabo. -3 plus 7. We add 7 to -3 to get 4. So let's try now and do that with the x coordinate here. If we added 7 to get to this x coordinate, then it means we add 7 as well to get to that one. So -7. We add 7 to -2. -2 plus 7, what does that give us? -2 plus 7 gives us what for the x coordinate here? Very good, Khatazo. We get 5. Hey, Khatazo is doing the thing. Khotazo. Thank you so much, Khotazo. We add 5. We add 7. We get 5. You see, we still get the same x coordinate that we had gotten when we checked with this side. Look at this one now. -2 to get to -3. What did we do to the -2 to get to -3? -2 to get to -3. -2 to get to -3. We subtract 1. Very good, Khotazo. Khotazo is on fire. Okay, we subtract -1. -2 minus 1 gives us -3. So we do the same thing here. We subtract 1 from 5. We subtract 1 here. 5 minus 1. What does that give us? The y coordinate of D, which is also 4. You see, we still consistently get the same x and y coordinate that we anticipated when we actually checked things here. So what am I saying to you? I'm saying that this approach by inspection works for all 4 types of palms. Okay, guys, these are types of palms. Parallelogram is a parallelogram in the truest sense, but I mean square, rhombus, rectangle. These are all types of parallelograms because they exhibit the major properties of a parallelogram, which are, the first one is both pairs of opposite sides are equal. Second one being both pairs of opposite sides are parallel. Third one being diagonals bisect each other. Fourth one being opposite angles are equal. So those properties apply to all these three quadrilaterals, including obviously the parallelogram itself, which is a parallelogram. Do you feel me, my brothers and sisters? Okay, someone said go back to 2.1. I did not understand. When you're done explaining, can you please Sisipho ziqwayi Sisipho? Sisipho, are you still here? Can you just indicate in the comment section that Sisipho, you are here? See. I will not continue, Sisi, until you tell me that you are here. Okay, you are still here. Listen up, Sisipho. This question was saying show that the values of A is equal to 5 and B is equal to -4. So Sisipho, you know almost how to calculate the midpoint of a given line segment. So if you are given a line segment and they say to you calculate the midpoint, you know how to calculate the midpoint, right? I just want you to say yes in the comment section. To calculate the midpoint straight, like you are given two endpoints and then they say calculate the midpoint. You know the formula that we use to calculate midpoint. The fact that you take your endpoints for x and y respectively, you divide them by 2. So you take the sum of the x coordinate first, you then divide that all by 2 to get the x coordinate of the midpoint. Then you take the sum of the y coordinates of the endpoints and then you divide by 2 to get the y coordinate of the midpoint. You know that, right? Now, this question here, you are given the midpoint. Are you with me, Sissy? You are given the midpoint. The midpoint is given to you. They are like, here is the midpoint, Sissy. Guess why? Ne? Guess why they give you the midpoint? Then you are missing the end point of the midpoint. You are missing one of the endpoints. You are not missing both. You are missing one. So if you look at the y coordinates, let's just first look at the y coordinates. A is the y coordinate that is unknown for the point A. Here it is. You don't know what that y coordinate is. But the y coordinate of the midpoint, you have it. Then you have the y coordinate of the other endpoint. So what do you do to find the endpoint when given the midpoint? This is what this thing is checking. So what I said is, simple. You say y coordinate of M. Of course, that y coordinate of M is your subject for your equation. Because when you want to find the y coordinate of M anyways, you would take the sum of the two y coordinates of your endpoint and then divide them by 2. So you set up an equation. Y coordinate of M is equal to y coordinate of A plus y coordinate of B divided by 2. Make sense? Then what is the y coordinate of M? You have it. It's given to you. It's -2. Equal y coordinate of A. What's the y coordinate of A? You don't know it. You use the letter A. There's the letter of A. Plus y coordinate of B. Y coordinate of B, you have it, -9. You put it in brackets. All divided by what? By 2. Now, Sissy, what do you have? An equation. You have to solve for who? You need to solve for A, Sissy. How do you solve for A? Well, you have a fraction. So what do? You find the LCD. The LCD here is 2. Okay, so you multiply each term by the LCD in the numerator. Since the LCD is 2, you multiply by 2 here in the numerator. The 2 and the 2 cancel. But what you do on one side, you do on the other side, which means you also multiply by 2 here in the numerator. 2 times -2 gives you -4. That leaves you with A plus brackets -9. A positive times a negative gives you a negative. A minus 9. You isolate Mr. A because you want to solve him. You take -9 over, he becomes positive. 9 minus 4, Sisipo, gives you 5. A is equal to 5, Sisipo. That's how you got the value of A. Are we together, Sisipo? Are you together? Oh, my daughter, Carl Lot 193. You must be going through a lot for you to be using such strong language in the comment section. Oh, may you be blessed, my guy. Something you must be going through a lot. I think all you need, Wena, is love in your life. You need love. Okay. All right. Thank you, Sisipo. Then we want B. B, Sisipo, ne, is here. B is also a what? A end point. But you are given, Sisipo, the x-coordinate of the midpoint. You see, Sisipo? There it is. And you also have the x-coordinate of the other endpoint, which is -2. So what do you do, Sisipo? You say the x-coordinate of M again, because you have it, which is what? -3. There it is, x-coordinate of M. You have it, -3. How would you find it? Usually you would say x-coordinate of A, the one endpoint, plus the x-coordinate of B, the other endpoint, divided by 2. We substitute. X-coordinate of M, -3, equal to x-coordinate of A is -2, plus x-coordinate of B, where's x-coordinate of B? It is B. There you write small letter B, the one that you want, all divided by 2. So since people, again, we play the what? That LCD game. LCD is 2, right? We multiply by 2 both sides. When we do, this cancels. 2 times -3 gives us -6. We transpose -2 over. When we take the -2 over, it becomes +2. -6 plus 2 gives us -4. B is equal to -4. Halala, halagasha, 140 kz, halagasha, 14 ba. They lost those guys 2-0. I corner. B is equal to -4. Too soon? I think it was too soon. Okay, B is equal to -4. Okay, we good now, Zizipo. I mean, you see now I'm taking the Z and the C. Boo! Po. All right. Okay, nice. All right. Let's move on to the next question, guys. 2.5. Calculate the lengths of BM and CM. BMW and CM. So BM, where is B? There is B. Where is M? There is M. They want the length of BM. Okay. Do we have the coordinates? Yes, we do. Remember, we found the small letter B. It's -4. So can we find the length of BM? I think we can, right? That shouldn't be too much of a problem. CM, where is C? Here is C. Where is M? There is M. Can we find the length of CM? Yes, we can. What do we use? I'm sure you guys know what we use to calculate the length of CM and BM. Remember, they did not stipulate here that we must round off, or they didn't say leave your answer in simplest set form. So we know we need to find these actual lengths. And after we do so, because there's no instruction, yes, Asenat, we use the distance formula. Eh? When I tried to invite you up here, and I could see why you are having nice chat conversations there in the background. Okay, calculate the length of BM and CM, or at least here you didn't say anything, it was silent. Calculate the length of BM and CM, use distance formula. It's straightforward here. We use the distance formula, and that should not be too much of a pain. It should be very straightforward. Beloved grade 10s, you see? Calculate the length of BM and CM. BM and CM. So B -4 and -9, M -3 and -2. Okay, distance formula. It's time to use the distance formula. XB minus XM, the whole thing squared, plus YB minus YM, the whole thing squared. We know how. We know. Okay, so guys, let's be careful here. Make sure that our coordinates are recorded correctly. There's no jokes, no funny business. We didn't write down the coordinates incorrectly. So the x coordinate of b, we have minus 4 minus x coordinate of m minus 3. Y coordinate of b, minus 9 minus minus 2. Okay, then we have negative 9 plus 2. Okay, for both lengths. Nice. Seems like you guys got the same sweet length for both. So we get 1 squared and we've got negative 7 squared. We've got 1 plus 49. Got 50. And yes, it's 5 root 2, guys. I know. Okay, all of you people are railing about you. Just put it in a calculator. Guys, I like I said, I don't have a calculator right now. That's why you see me doing everything step by step, and you're like, put in a calculator. So please, have a break. Have a Kit Kat, guys. Have a Kit Kat. All of you need to have a break. Have a Kit Kat. CM for negative 3, and negative 2. Bring it back, sing it back, bring it back to me. Ndus is like, bring me back. I'm gonna bring you back just now, brother. Bring you back just now. X coordinate of C, boom, minus 3. Y coordinate of C, minus 4 minus 2. Square root everything. So we have 4 plus 3 plus C and negative 3 plus 2. We put everything there in the squares. Get negative 1, the whole thing squared, put it all underneath the square root. We get 49 plus 1. Seems like we get the same beautiful freaking answer. 5 root 2. Yeah, and guys, remember that when they have basically said nothing about leaving it in simplest set form, can I just ask someone to put this into the calculator and then to indicate for me round it off to 2 decimal places? Because remember, that's what we have to then do if they are silent about set form and stuff. Okay, if they didn't say anything about set form, then what do? We revert back to what is stated in the instructions and information. Round off answers to 2 decimal places unless stated otherwise. So please, guys, round off answers to 2 decimal places. Are we together? Yeah. So it is your prerogative to do so when it has not been stated. But if they say leave in said form, then you would have left the answer here. But because they are silent about said form, then it is our responsibility to make sure we leave answers round off to the appropriate decimal place so that we do not find ourselves in trouble with anyone. Make sense? Are we together, people? Are we together? Are we together there? I hope we are together, guys, because it's important to be together there. Linda Kushle one day is like, yabo. Ndusi is like, yes, malume. Sizzy Pusquayi is like, yes. Right, okay. Well, if we're all together, then that's fine. Okay. It is well with the soul. Calculate the area of quadrilateral BMDC. Calculate the area of quadrilateral BMDC. Very interesting. BMDC. Thank you, Junior, for the TikTok. Thank you, Junior, for the TikTok. Yeah, they said quadrilateral, right? And that's the interesting thing there. They said quadrilateral. Okay. Mark allocation is 4 marks. BMDC. Yeah. So remember, we have the coordinates of D, right? And I guess what we need to first establish is what type of quadrilateral do we have there? BMDC. Because remember, if we are aware what type of quadrilateral it is, then we should be good as far as calculating its area. Do we have an idea? Because remember, we had ADCM, right? And remember, ADCM, if you remember very well. Okay, seems like this one is giving same vibes. Now we have BMDC that we need to calculate the area for. Makes sense. All right, does that make sense? Yeah. It's nice how people say you can indicate using a pencil. I think, let me redraw this diagram, because the thing is, unfortunately, you see, I am under-resourced. Okay. Maybe now you'll understand why I need gifts in my life. Thank you, Junior, by the way. Junior, I think, understands the mission, that sometimes this guy needs them gifts. If he gets them gifts, then he can resource himself and stock up, and then he won't be a pain. He won't be such a pain. Okay. All right, so let's try and do this. I guess the fact that it's an isosceles, that's what helps us out a lot, eh? Yeah. Makes sense. Makes sense. Okay, so this is very rough, guys. Like, yeah, so don't shoot the guy. Don't shoot the guy. Remember, this is grade 10, guys. Grade 10, whatchamacallit? It's grade 10, Trig and Analytical. So I'll only be doing Euclid tomorrow, hopefully. Same time, same place, same situation, same, yeah. After this question, I'm gonna do an trigonometry, yeah. Okay. So our A value was -2 and 5. So don't forget that. B, grade 10. What grade did you think we were doing, little Goshle? I want. Why do I sense that you thought you were doing grade? I thought it was a grade 12 or something. This is like grade 10, bro. But you would know. She thinks it's 11. Really? It's a pity. Nah, fab, nah. It ain't 11. But yeah, you know, concepts in grade 11. Oh, you're in 11. Oh, I can't. I get. Sorry, buddy. Sorry there. Sorry. -3, -2, that's -4, -9. Yeah, that's a good question, Asanati. I'm also interested to know Mr. 38 in Dusi. What grade is he in? I see taxis in his profile picture. I'm also very much interested to know what grade he is in. It would make my my moment as well. Yeah. Okay, so we have BM. So what does it say? BMDC. BM. So let's just say okay, so let's just put here D. That D, we got the points, Moss, from the previous problem. Is Ndosi going to open up about what grade he's in? Because that would be nice to know, hey? Oh, D was 5 and 4. 5 and 4. Okay. AB, we had the length of AB, right? The whole entire length of AB we had gotten, because we need to establish some few things there. AB, the AB length was 10 root 2, the whole length. Then we found out that BM is 5 root 2, so that was also 5 root 2. So we have 5 root 2. Now, interestingly enough, CM we also found is 5 root 2. Interesting. So 5 root 2 there. Yeah. Asenati. I only help my science neighbors with maths and physics. Now the cookie is crumbling there, hey? As to what is actually happening there with Mr. Ndusur. Okay. So guys, with this one, we're supposed to calculate the area of quadrilateral BMDC. So where we have it here, BMDC. So this is the rough sketch of BMDC. Okay. Yeah. So it's very helpful when we know the type of quadrilateral we are dealing with, right? So that we can then be able to calculate the area of the quadrilateral, no questions asked. Okay. So as I am here, any beautiful ideas? Right. Remember, we had proven by calculations that CM is perpendicular. Let's not forget that. So we had shown that CM is perpendicular to who? To M. CM is perpendicular to AB. Okay. All right. So that was very important for us to note, because we can calculate the area of this triangle as a result. Area of this triangle, right? And obviously that would mean that this triangle as well, the area of this triangle and the area of this triangle. In fact, if I have the area of this triangle, I'll pretty much be able to do what? To calculate the area of the entire quadrilateral by adding the two triangles. Okay. Yeah. So if I can calculate the area of this triangle, then I will add these two together and then have the area of the entire quad. That is basically what I was hoping to sort of like analyze with this. Okay. As an it's a rectangle, and Mr. gave a suggestion of half base times height. Yeah, half base times height. Okay. Yeah, half base times height for triangle CMB. that would be an appropriate one. Half base times height for triangle CMB. Then you double it and you get the entire. But I think for me, okay. Oh, that's fine. If then that's what you were meaning, then that's fine. So we can come here then and say area of triangle CMB. First and foremost, you can say area is equal to half. Now, which one is the base here? Base would be MB times CM. MB times CM. So thankfully, we already have those MB and CM. So we can just revert to 5 root 2 times 5 root 2. Okay. And what's half 5 root 2 times 5 root 2? 5 times 5 is 25. And obviously the root 2 times root 2 is going to be 2. So 25 times 2 is 50. 50 divided by 2 is 25. 50 divided by 2 is 25. 25 what? 25 units squared. Okay. So area of BMDC will be equal to 2 times the area of triangle CMB. So we can say 2 times 25 units squared. That will give us 50 units squared. And that is a very good outcome to have had about the quadrilateral BMDC. And we are very happy people, because it is happiness that we seek and nothing else. Okay, so guys, that was some freaking analytical geometry. Okay, maybe let's look at another question very quickly. Analytical. I'm just thinking this is another paper too, June 2025. But this was June. This was the one that I just did was taken from a November paper. This one is June 2025. Let's just look at the analytical. I think I'll use the rest of the time up until 11 to just finish off this analytical geometry question, and then we'll get into the last hour until 12. We'll do no, grade 10 doesn't have angle of inclination, my guy. Grade 10 does not have that. It's grade 11 that has that. Let's allow the grade 10s to have their fun with what they are doing. So here we go. Yeah, and to see when you are a tutor, my guy. So you are here to eat the children's food. We must allow the children to eat the children's food, not grade 10. Grade 10 is the grade we're busy with, guys. It's grade 10 all the way. Grade 10 all the way. Grade 10 all the way. Children's food. yeah, I want these kids to come here and join. These kids must come and join here. Yeah, I found you out thanks to Asenati asking questions. You see, now we know. Asenati.
Yes, sir.
Yeah, you helped us find to see that he's not a student, he's a tutor. That one. Good job. You've got amazing investigative skills. I think we need to deploy you. Yeah, I think you've got superb investigator skills there. Do you want to help me with this question, the one that's coming up? Yeah, Junior, I see you there. I hope you're well, buddy boy. Are you well?
I am well, sir. What about you?
No, yeah, I'm trying, Michael. I'm trying today. I'm trying, just hoping I won't be crying. I'm just trying. Yeah. All right. Asenati, in the sketch below, P negative 6 and 1, Q 2 and 4, and the R 8 and 1, and S, X, Y are vertices of quadrilateral PQRS, with QR being parallel to PS. So let's just observe a little bit there. There are the points as they set them: Q2 and 4, R8 and 1, S, X and Y indeed is there, P, -6 and 1, like they said it in the statement. And then they said they are vertices of a quadrilateral. Now PQRS. Then they said QR. Where's QR? Here is QR. They say QR is parallel to PS. You can see even the lines there with the arrows to indicate the parallel state. Okay. Yeah. So Asenati, are you ready to answer this question? What type of quadrilateral is PQRS on the basis of these the information given?
It's a rhombus.
It's a rhombus. Why are you saying it's a rhombus?
Yes.
Why are you saying it's a rhombus?
Because the opposite sides are parallel. Opposite sides is a parallel.
Because the opposite sides are parallel. Is that your final
Yes,
answer?
sir.
Is that your final answer, Asenati?
Yeah.
Yeah. All right. So rhombus, Rombi. So you are saying this is Rombi.
Yes, sir. You are making me doubt myself now.
I've decided to wipe out the comment section so nobody can help you in the comment section and give you ideas. So even themselves, they're probably like, what in the world? Come back, let us comment. What is wrong with you? And I'm like, nah. Okay, Asenati, I am making you doubt yourself because I want you to doubt yourself. There's something that I think maybe you are missing. You are saying it's a rhombus. What other properties do you know about a rhombus? You said opposite sides are parallel. But like, what else do we know about a rhombus?
I'm not sure, sir, but
And
I'm not sure about the opposite side.
you're not sure. Okay, so here, Asenati, it's only this side that is parallel. Okay, and lines that are parallel, it's one pair here. So this cannot be a rhombus because it's only one pair of sides that are parallel. Junior,
Yes, sir.
one pair of opposite sides that are parallel, is that a rhombus?
No, sir.
Okay, so can you explain to Asenati what it is? I'm hoping you will tell me the right one. As Asenati pages through, are you the one paging through? Is it Asenati?
Yes, it's me, sir.
Oh, okay, that's
Checking to my
beautiful.
nose because I am yes.
Very good, very good. I'm so proud of you, Asenati. Yo. Even the audience is clapping for you. Junior,
Yes, sir.
what type of quadrilateral is this one?
Parallelogram, sir.
Parallelogram. Asenati, do you agree? Okay, Asenati,
But I don't agree.
you don't agree, ne?
Yes.
Okay. I think it's fine.
Sir, now I found it.
Now you finally found it.
Trapezium.
It's a what?
Trapezium.
Chini Asenati, this girl. Hey, Asenati, you nearly did not find it, eh? You nearly did not find it. What made you so sure that it's a trapezium?
Okay, so I'm not gonna lie, I just saw it in my notes now because like we all have the properties and ways to like to prove quadrilaterals. So I just saw now. I was studying them, but I don't know how I forget.
No problem, Asenati. You see now, so at least now us being here together like this is going to help, you see. Yeah. So just read what it says there about a trapezium for us in your notes, because so that it's coming from a place of authority, not from me.
It says one pair of opposite sides are parallel.
One pair. Oh, so it's like a pair of shoes. You see, one pair of shoes. Most as an you don't you wear one pair of shoes, most.
Yes, sir.
Yeah, one shoe, another shoe. So one pair of opposite sides are parallel. Just one for a what? For a
For a
trapezium.
trapeze.
But Asenat, remember, I think like 3 minutes ago, you said rhombus. Why did you say rhombus when you were looking at this one?
Because a rhombus is also like skew, it's not straight. So like in my mind I was like, okay, rhombus. I didn't actually think of a trapezium.
Oh, it's skew. Oh, it's the skew part.
Yes, sir.
But if you read from your notes, if you can read from the properties of a rhombus, what does it say?
There's one pair of adjacent sides are equal and diagonals bisect at 90 degrees.
Wait. That first property you said?
One pair of adjacent sides are equal.
Can you tell me in this particular shape, which sides would you regard as your adjacent sides? Just give me a pair here of adjacent sides. Example.
PQ and SR.
Okay, PQ and
SR.
SR. So you are saying PQ and SR are adjacent sides?
Yes, sir.
What does the word adjacent mean, Asenat?
Opposite sides.
Nope. Adjacent and opposite don't mean the same thing. Look at PQ. You see PQ?
Yes, sir, number one.
Yeah, PQ is adjacent to QR, Asenat. QR and PQ are called adjacent. The word adjacent means what? Next to. Next to. Okay?
Yes, sir.
Yeah, so QR and PQ are called adjacent. So the word adjacent means next to.
It's true.
Next to is different from opposite. So PQ, when you said PQ is adjacent to SR, but in actual fact, PQ is opposite SR. Are we together?
Yes, sir.
So these are opposite side, but PQ and QR are adjacent. Just like PQ and PS are adjacent.
Yes.
That's what we call adjacent sides. Okay?
Yes, sir. Ngiyibona.
Yeah, you must bona it, yes, and otherwise, hey, if you don't bona it, it will not be able to bona you if you don't bona it. Yeah. Okay. Then what other properties do you have there?
For rhombus, diagonals that bisect at 90 degrees.
Okay, diagonals bisected 90. Do you know what diagonals are?
The lines that cut in between, like QS. The lines
Okay,
going to be
yes.
cutting with QS in between.
Yes, definitely. QS is it would be a diagonal if there was a line connecting there. And what other line is a diagonal?
The line of PR.
Exactly. Thank you. Okay, you get the point. Okay, give me another property of a rhombus.
Diagonals that bisect the corner angles.
Okay,
Sides equal in length.
Okay, sides equal in length. That's why Asenati, I was like thinking to myself, if you are saying this is a rhombus, are you trying to tell me that these sides, all of them, are equal in length? Hey, I was like, hey, Asenati, this side equals that side to that side and that side. They're all equal, these sides.
No, sir, I forgot you.
Yeah, I know. I'm just trying to show you how bad it was that you forgot, you know. So I'm hoping that you will feel this and you will never want to feel like this ever again. Yeah. So I hope we're good now, Asenati. I can move away more. I think we got the point. So this is a, one more time, you said, Asenati, this is a?
Trapezium.
Amen. Thank you very much. And the reason why you're saying it's a trapezium is because?
One pair of opposite sides. One pair of opposite one pair of opposite sides are parallel.
Amen. Hallelujah. Yeah, the audience is impressed. No, the audience is like, it's bad. They like wowed, wow, Asenati. What type of quadrilateral is PQRS? Asenati told us it's a trapezium. She even has like backup reasoning for why it's a trapezium. One pair of opposite sides are parallel. Thank you so much, Asenati. We've learned so much tonight. Okay, 1.2. Determine the equation of QR. Junior.
Yes, sir.
Yeah, you've been a junior there. I think I called you. You must call yourself senior. Didn't I say that?
Ah, you did, sir.
Yeah. Because that day in that live, you were doing serious stuff there. Senior stuff, not junior stuff anymore.
Yes, sir.
Yeah. So are you ready to help us with determining the equation of QR? How do we go about doing that, my guy?
Let's just say we find the gradient of M of the line passing through Q and R.
Okay, the gradient. How do we find the gradient, my guy? I forgot about that thing. I don't know how you find gradient.
MQR.
Wait. Let me. What did I just do now?
Then X1.
So MQR. Okay. MQR. Right?
Is equal to Y2
Okay, Y2, yes.
minus Y1 over X2 minus X1.
Okay. All right. Thank you. So just give them to me. What would be my Y2?
The Y2 will be the 1 minus 4.
Y?
Minus 4.
Minus 4. Okay, in the numerator, thank you. Then X2?
8. Then 8 minus 2.
8 minus 2. Okay, that's what I've substituted according to what you've said. Okay, then continue on for me.
Then it's going to be equal. Then 1 minus 4 is going to be equal to minus 3.
Okay.
Over 6.
Over 6. Okay. Then
it's going to be equal to minus 1 and over 2.
Okay, thank you very much. The gradient, I think, is 100%. I think, I'm not so sure. Asenati, can you confirm for me? Is this gradient correct? Is Junior really giving us the senior stuff?
Yes, I can confirm.
Oh, okay. I get beautiful. Junior, you can see it's not even me who confirmed. It's Asenati, the one who knows the trapezium and its properties.
Yes.
Then we want the equation. That's the gradient. What else do we need?
Now we use the slope point form.
Okay.
Point 2, 2, 4. It's point Q and 4, 2, 4.
Okay, so Q, which is 2, 4.
Y minus Y1 is equal to M open bracket X minus 1.
X minus 1?
Yes, sir.
X minus 1?
So X1, sir.
Oh, okay.
Then it's gonna be Y minus 4 equal to minus 1 over 2.
Okay, minus 1 over 2, the one we just got, yeah?
Then open bracket, then write X minus 2.
Okay.
Then it's gonna be also write Y minus 4 is equal to Y minus 1 over 2 X plus 1.
All right.
Then our equation will be Y is equal to minus 1 over 2X plus 5.
Yeah. Okay. Hey, I mean, Asenati, hey, have you seen such?
I'm confused now because, like,
Tell me, what are you confused
Equations
about?
now that I have. Like, hi sir, I'm gonna say when like the outcome because equation. I thought of like in my mind when I thought of equation, I thought of y equals to mx plus c.
Okay, let's do it with that
Yeah.
one. Asenati, give it to us. Give it to us. How would you do it? You have the gradient, it's negative half, and you have the points as well for both your Q and your R. So what would you have done? Q and R is 8 and 1. How would you have finished it off? Because you said you know this one, you don't know the other one, which is fine. Let's just explore this one and see if it will lead us to the same answer or something different. There's the gradient.
Like, what was the
negative.
question again, sir? Like,
We want to find the equation, Asenat. So we already found the gradient. It's negative half. Now you are saying from this point, you would have said y is equal to mx plus c. Then
put 1/2 kwenda ka m.
so we put negative half in the place of m. Yes.
Uc is the y-intercept.
Yes, it is, but we don't have the y-intercept. But we only have the points that lie on the line. So what do we do to find c?
We take 1 point that lies on the line, put
Okay.
y in down ka.
So which point must I take?
Like 1.
Which
I
one
can
must I
take you. I will take with you.
Okay, so we are going to substitute Q, which is 2 and 4.
Q.
Okay, then
Then I'll put 4 in the place of y.
okay, so this is my x and my y. I'm going to put 4 in the place of y, as you said, then
Then -1/2 bracket the 2
okay,
x plus c, so we can get c.
okay,
And then see, wait, 1 then the -1/2 times 2 will give us -1.
okay, yes, then
C then c will give us 5.
okay, then
C will give us
yeah, C will give us 5, as you said. Took the -1 over, it becomes +1. 4 plus 1 is 5. You're right, C does give us 5.
Yeah.
Then the equation?
Then therefore 1/2
Y is equal to -1/2.
plus the 5.
1/2 what?
Wait, no. The 2 times it by 1
-1/2.
x.
Okay, x.
I forgot the x plus 5.
Yeah, that's what you forgot. I was actually wanting you to remember that. Okay, if I look at both your answers, look at his answer, look at your answer.
It's the same.
It's the same, it's the same. So it's a matter of what? Method. Junior, what grade are you in again?
This, so that.
Grade 10, sir.
Grade 10. So are you telling me that your sir taught you this beautiful formula to find the equation of a straight line? Or your ma'am? Is it your ma'am or your sir? Sorry.
It's a ma'am, sir.
Okay, so ma'am taught you this formula.
Yes, sir.
Yeah, hey, ma'am doesn't mess around. And then Asenati, of course, ma'am or sir exposed us to this formula.
Yes, my sir.
Oh, sorry, your sir. Okay, epic. So all in all, yeah, as you can see, these are both respectively viable ways to find the equation of a straight line. Okay. Okay.
Yes.
So we stick to what your ma'am or your sir taught you, so that you can actually they may not be persuaded otherwise, because of course they'll mark you consistently, right, if you use the method that they have taught you, right?
Yes.
Yeah. Otherwise, look at that, man. Like, this was amazing, hey? Now imagine if this is gonna be the red pen doing these things to your script when you get marked, and the marks you get, you see?
Yes.
Yeah, the red pen must do this to your script. The red pen cannot afford to be doing these things to your script, man. You know? Yeah.
Yo, it's a
Yeah.
lot.
Yeah. You know? Full marks. All right. So that was well done. You guys tag team that one very well. Like the junior and Asenati team, hey? Don't mess around. Okay. 1.3. It is further given. Okay, guys, so here's the thing. Here's something else to note. Look at the line QR. We were supposed to get the equation. Look at the line QR. If you look at the way that this line is sloping, it is sloping downwards. It's not sloping up, it's sloping downwards. So what do we know about a line that slopes downwards as far as its gradient? Is it positive or negative? If you have a
It's
line,
negative.
yeah, if it's sloping downwards, the gradient is negative. So when you are doing your calculations and your calculation comes out as negative because you can see the direction of the line agrees, then that's one of the things that confirms for you, the person who's doing the calculation, that what you are doing is correct. Or at least it gives you a sense of confidence in what you have done. So these are ways that you can also check for yourself that, okay, am I on the right path or not? Okay.
Yes.
Yeah. So let's go down now to the next question, 1.3. It is saying 1.3. It is further given that the diagonals of PQRS are perpendicular to each other. Where's PQRS? Diagonals of PQRS. So the diagonals, I think Asenati earlier on did indicate which ones would be the diagonals. Asenati, you said the diagonals would be
PQ and QR.
Say that again.
Yo, I'm entering adjacent size. PQ, QS, and PR.
Thank you. Hey, I was like, hey, what's happening now, Asenati? Well, yeah. Okay. Yeah, thank goodness. Thank goodness that was just a slip. Because I was like, yo, from adjacent to, yeah. Anyway, it is further given that the diagonals of PQRS are perpendicular to each other. Determine the coordinates of who? Of S.
Yes.
If the what? If the diagonals are?
Perpendicular.
Yeah, that is the keyword. So, Junior, do you want to junior it out, or Asenati, do you want to give it a crack? Who wants to give it? Who's giving it a crack?
I can try first, sir.
Okay, let's go, Junior. Okay.
No, sir. She can try.
Oh, she can. Oh,
giving
ladies
it to me.
first. You're such a gentleman.
Yeah.
Wow. Such a gentleman.
What?
Such a gentleman. Like, that's such a gentleman, this guy. Man, I think that, oh my goodness, I'm so touched. Now I'm so touched by this, like, gentlemanness. Like, we need more young men that are like this, that have such gentleman qualities. You know, it's so amazing. It's so touching. Like, I'm so touched. Like, on a Saturday night, this guy is showing such gentleman qualities. Yeah, Asenati, I like this. This is amazing.
It's amazing.
Yeah, it is. It's touching. Like, it's so touching in a world that has become, you know, where people lack such gentleman qualities. Like, it's so touching.
Yeah.
Yeah. I'm glad that you finally agree, because for a moment I was thinking that you do not see things in the same light. Okay. All right. So we can go.
Okay, sir, but though,
What do you
like,
think?
the way I wanted to approach it was the gradients. If we times the gradients of these perpendicular lines, then if they give us -1, then we can be sure about perpendicular and also get the coordinates of S.
Okay, all right, okay. I hear you. So you're saying to determine the coordinates here, we can use the concept of perpendicular lines. So the product, right, of the gradients would give us -1, you say?
Yes.
Okay, right.
Oh, you remember, Ngoka, when you said like the number you add or take out in a like the number we add and the x that will give us the next x-intercept, then the number we add or minus on the y-intercept that will give us the next y-intercept that will
Yeah, I remember
determine
that.
our y and x value.
Mm-hmm.
We can use that one too.
With that one, here in this situation, remember, what did you say? What did you say is the type of quadrilateral PQRS in this case is? You said the quadrilateral is?
A trapezium.
Yeah, and if you remember what I said about that earlier on, I said that method can be applied to all types of what?
Only two of these. Palms, parallelograms.
Yeah, all types of parallelograms. So your parallelogram, square, rhombus, rectangle, that's fine to apply. But if it's not any of the above, then icona. Yeah, it don't happen, right? So I think what we can do with what you've said, we can definitely utilize the fact that the product, because we're further given that diagonals of PQRS are perpendicular to each other. Remember, what did we just determine? We determined the equation of QR. Just not so long ago, we determined the equation of QR. Yeah.
Yes.
So if we know the equation of QR, then it means we can find the equation of...
Yes.
Yeah, we can find the equation of QS, of course, like no doubt about it. We can find the equation of QS. But I think more than that, we also know that if these two lines are parallel, then what do we know about their gradients?
Gradients are equal.
Sorry?
They will share the same gradient.
Yeah, they will share the same gradient. So the gradients will also be equal. Okay. So that means we can actually then formulate another equation in terms of x for this particular line. And then of course we can use the two equations and solve them simultaneously and get x and y for this point. Yeah. Because like I said, we only know that this is a trapezium. We don't know anything more than that. But as it says here, it says that if it is further given that the diagonals of PQRs are perpendicular to each other, determine the coordinates of S, which is quite interesting. Because if the lines are parallel and the diagonals, they are actually perpendicular, that is a very interesting thing as well that we're learning there. Okay, so enough with the talking. Where do I start? Let's see if you guys can lead me along. I want to be led. I don't want to lead.
Calculating the gradients, Kaloka.
Sorry? Calculate the?
The gradients.
Calculate the gradients of?
QR.
Calculate the gradient of QR. So I must calculate the gradient of QR. Okay, so let's do this.
Jimmy, why don't you start that?
So gradient of QR times the gradient of RP. what is it going to be equal to? Negative 1, because we are told most that it's perpendicular. Yeah, so gradient of QR. So where's Q? R? No, not QR, man. Gradient of QS. You see now, me is doing funny things. Gradient of QS and gradient of RP. Yeah. So QS, so we are going to say 4 minus y over x minus 2. 4 minus y over 2 minus x, sorry. 4 minus y over 2 minus x multiplied. Gradient of RP, 1 minus 1 over 1 minus 1. Very interesting. 1 minus 1 over 8 minus 8 plus 6. 8 minus minus 6, which is equal to negative 1. Okay. So 1 minus 1. Do you see this, guys? RP, they have the same y values.
Yes.
So 1 minus 1, 8 minus minus 6, which is 8 plus 6. Okay, so let's just do this. 4 minus y over 2 minus x times, what's 1 minus 1 there?
0.
0 over 14. This is interesting. This is very interesting. What's 0 divided by 14?
0.
This is very interesting. Okay, then what's 4 minus y over 2 minus x times 0? Do you see this, guys?
Hi.
0 is equal to negative 1.
No.
Look at this. Look at this, guys. Look. The gradient must at the top 4 minus y
Yes.
over 2 minus x.
Yes.
Do we agree? That's the gradient of QS.
We agree.
Then for PR, 1 minus 1 over 8 minus minus x, which is 8 plus 6, which is 14. Okay, are we together? Yeah. So we have 4 minus y over 2 minus, 4 minus y over 2 minus x times 0 over 14, which is equal to negative 1.
Oh, just
Okay.
Okay.
don't you cross multiply back, go to y minus x to that 0, then for y minus y.
Which to y? Remember that something
Here on
times by 0.
it's 0. Oh, so then
So then I have 0 is equal to negative 1.
we left with that for y minus 4 minus y times that 14. And we
Sorry?
cross multiply these. And we're gonna be left with the 4 minus y times 14 because we cross multiply.
Saying how am I? Aren't I going to be left with?
Yes.
Yeah. So there's something I want you guys to see by this, right? So obviously the multiplication. So this basically means there's no solution, right?
Yes.
Yeah. So listen up, and I want you to listen well. if you have your y-axis and you have your x-axis, okay?
Yes, sir.
Are you following me? If you have your y-axis and you have your x-axis, isn't your y-axis and your x-axis perpendicular?
Yes, sir.
Yeah. But if you calculated your gradient for your y-axis, okay, wouldn't you get a gradient that is undefined?
Yes, I would.
You would, right? And if you
Yes, sir.
calculated your gradient for your x-axis, wouldn't you get a gradient that is equal to 0?
Yes, I would.
Yeah. So this is a typical example because the gradient of RP, okay,
Yes.
since your y values are the same, look, since your y values are the same, that
Yes.
means this is a horizontal line.
Yes,
Yeah.
yes.
And then if, as they say in the statement, since as they say in the statement that this diagonal is perpendicular to that one, that means this is a vertical line.
Yes.
In as much as this is a horizontal line, this is a vertical line.
Vertical line.
And this here is showing you that this is evidence, okay? This RP is a horizontal line. This RP is a horizontal line, and this has to be a vertical line because there's no ways that these two lines will be perpendicular unless this is a vertical line.
Yes.
But then note something here. There's something that we know about a vertical line when it comes to its x coordinates. So if Q here is 2, what is your x coordinate of S?
It's also 2, sir.
Yeah. And this is what I wanted to sort of like reveal by this question. Okay? Because let me tell you this, if let's say you applied this and then you got to a place where you're like, I'm getting 0 is equal to -1. Of course, what this means, it means that there is no solution. But then it is implied by the fact that if you have a horizontal line, your gradient is 0 for that horizontal line. And the line that would be perpendicular to a horizontal line is going to be a vertical line whose gradient is always undefined. A vertical line has an undefined gradient. The gradient is not defined. Why? Because in the denominator, when you subtract those x values in the denominator, when you are calculating the gradient for a vertical line, the gradient will give you 0 in the denominator. I mean, sorry, the denominator will be 0 when you subtract the denominators. Yeah. Because why? The x values are the same.
Yes.
Yeah. So to calculate the coordinates of S here, you need to find the x coordinate by inspection, which obviously, because you know this line is vertical, because this one is horizontal. So this is always true about perpendicular lines. A horizontal line will always be perpendicular to a vertical line, and that vertical line will be having a undefined gradient.
Yes.
Yeah, and this is an important, like, a conceptual turning point. If, like, let's say for instance you were not aware of this, I need you to be aware of it now, because as I am saying to you, your vertical y-axis is perpendicular to your horizontal x-axis, but your horizontal x-axis has a gradient which is 0. And obviously, then the vertical line, its gradient will be undefined. Okay? But we say the two lines are what? Are perpendicular. All right? Yeah. So lock into that particular point. So S here we are going to say S is actually 2 and Y. We don't know what the Y value is.
Yes.
But, like you guys said earlier on, we know that these two lines are parallel. We can find the equation of this line because for this line PS, okay, the equation of PS, we can find the gradient, and then 2, we can use point P, which is -6 and 1, to find the y-intercept, which is C.
Yes, sir.
Yeah. So we can find the gradient, the equation of SP, because we know that the gradient of QR is equal to the gradient of SP, which is equal to -half. Why do we say so? It's because QR is parallel to PS, and that is something that is given to us already. So we can then say y is equal to -half x, and then maybe just going by SNRT's formulation. Of course, we can go by your formulation as well, Mr. Junior.
Yes, sir.
Senior.
Yeah, now he's demanding to be called senior. Okay, no, it's fine. I'll call you senior. Wow, I've never seen someone be so adamant that I utilize the name that I gave them. Okay, yeah, we can use that one. Y is equal to -half x plus c. We have the gradient of PS because we know the gradient of QR because the lines are parallel. QR we got earlier on from calculation that it's -half. So gradient of QR is equal to the gradient of SP, which is equal to -half because QR is parallel to PS. So Y is equal to -half. We sub Asenati. We are going to substitute which point? P, -6 and 1. This point.
Yes, sir.
So that we can find the equation of this line. Yeah, so we can go ahead now and Y is equal to -half. Okay, so in the place of Y, we are going to substitute 1. In the place of X, we are going to substitute -6 plus C. We come to Mr. Senior's method, Y minus Y1. Y minus 1 is equal to -half X minus -6. So I'm just going to say X minus -6 is X plus 6.
Yes, sir.
Then we do the distribution. -half X minus 3. We take the -1 over plus 1. That gives us -half X minus 2, which is basically the equation. If we come back to Asenati's method, 1 is equal to 3 plus C. Take the 3 over. 1 minus 3 is equal to C. C is equal to -2. So therefore, the equation is -half X minus 2. So the equation is fine. We have that. Conclude, therefore, that if we have that, Y is equal to -half. Let's go and substitute this X value, S2 and Y. Yeah. So we are going to take the 2, substitute it into the equation because that point lies on the side. Yeah.
Yes.
No, that Y is going to stay Y. We want Y. That's what we want. Oh, is that when you solved it, you got 0?
No, like I was thinking if you want to find Y, first step is okay.
No, we're just gonna find the Y. That corresponding Y value that we get is going to be the Y value we substitute there. So -half times 2, that gives us -1.
1 minus 2.
Yeah, which is -3.
Yes, sir.
So the S is going to be 2 and negative 3.
3.
So when we look at that point there, does it make sense that x is 2? Yes, because the x values here are positive. Does it make sense that the y value is negative 3? Yes, because the y values
Yes.
in this
So
quadrant
y
are
values are
negative.
negative.
Yeah, so it makes perfect sense. S is equal to 2 and negative 3. Okay. So that question, hey, my man.
Quite tricky a little bit.
Yeah, a little bit, because most people would be thrown off by the fact that, hi, but what's happening here? Okay, yeah, because even me initially, you see, it was a matter of actually, had I observed the points a little bit more closely, the minute they said it is further given that the diagonals of PQRS are perpendicular to each other, then I look at the diagonals. What do we observe? This diagonal is horizontal. Why? Because it has the same y values. A horizontal line, guys, has a constant y value. It's horizontal. Then if it is perpendicular to a line, then that means that horizontal is perpendicular to a vertical line. What is the thing about a vertical line? Vertical line has an undefined gradient. So practically speaking, we just know the lines are perpendicular. And therefore, that the fact that it's the gradient is undefined, then that also speaks to the same x values for x, for q and s. You know, yeah. Yeah. So that is basically the trick that was behind all of that. Do that there. Okay.
Yes.
So I hope we've gotten that one, like at least get the understanding of it. You know, horizontal and perpendicular lines. Horizontal line and a vertical line may be perpendicular, but it also then obviously means that the horizontal line has the same y values, the vertical line has the same x values. Yeah.
X values.
1.3.2, you're asking, is PQRS a rhombus? Explain your answer. Now this is interesting. Is PQRS a rhombus? PQRS.
No, sir. It's not a rhombus.
Whoa, how come? Look at this. Look at this 3 marks, eh?
First of all, sir, the opposite sides are not parallel. Are not parallel.
Equal.
The opposite sides are not parallel.
Yes, sir.
Did you check?
Opposite sides are not equal.
Did you check? That's my question. Like, if you're saying that, did you check? Okay, because for instance, remember, these sides are parallel, and I guess my question is, did you check if these sides are, because if I find that these sides are parallel, then game over. This is actually a rhombus, guys.
Hey.
If let's come here. Let's go. In fact, you guys do it. You know most now that the coordinates of S are 2 and negative 3. Can you do that for me? Or maybe what you can do is calculate the midpoint of QS and PR and check if the midpoints are shared. Guys, if the midpoints are the same, if you calculate the midpoint of QS and the midpoint of of PR, and you find out that the midpoints are the same, this is a rhombus.
Game over.
It's a rhombus. So please do that for me. Find the midpoint of QS, check what it is, and then find the midpoint of PR. If they are shared, guys, it's a rhombus, this one.
Oh,
So it's not just a trapezium, it's a rhombus. So check for me. Do the calculation. Let's see. Use the midpoint formula. Check if what is the midpoint of QS. Check what's the midpoint of PR. Let me switch off the comment section for now so that you don't get influenced. You are all alone.
Okay, nothing. I just wanted to see clearly the coordinates of P. Okay. Yeah.
Oh.
X.
Okay, are we winning?
All I know, sir.
Oh, I thought you got it. So midpoint of QS.
I said don't calculate yet.
Oh, I thought you guys were done. Yo, that was a long time.
Don't. Right.
I thought you.
I'm almost done. Unless Asinat is already done.
We're waiting for you, Sonia.
Oh my goodness, you guys. I'm waiting for you, Senior.
I'm almost done. Okay, we can proceed.
What did you guys get? So for the midpoint of FR of SQ, what do you guys get?
SQ.
Yeah, the midpoint of SQ.
I got 2 in the x values and 1/2 for the y.
Okay, so you got 2 and 1/2. Is that your midpoint as well, junior or senior?
Yes, sir. Yes, sir. It's also my midpoint.
Okay, then for the midpoint of PR, what do you guys get?
I got 1 and 1.
1 and 1. Okay, is that true for you, junior?
Yes, sir.
Yes, sir. It's also PR. Oh, 1
Okay.
on 1.
Okay, okay. Then that means that the midpoints are not shared, right?
Yes, sir.
Yeah, which means the diagonals don't actually bisect each other.
Bisect.
Yeah, they don't. So if they don't bisect, then it means it's not a rhombus. It's not a
Yes,
rhombus.
sir.
Yeah. But guys, had you actually found that it does? If it would have happened that your midpoints are shared, remember, it would mean two things. It would first mean that your diagonals firstly are perpendicular. You know, if they are perpendicular and they bisect, guys, meaning they have a shared midpoint for the diagonals, then we know that a quadrilateral that has diagonals that bisect at 90, that is called a what? A rhombus.
A rhombus.
I repeat, a quadrilateral that has diagonals that bisect at 90 degrees, that's called a rhombus. So when we did that calculation, it was to verify whether the lines bisect, because we already know that they are perpendicular, the diagonals, but we wanted to check if they also do what? Bisect. But we found that the midpoints are not shared, which means that the lines do not bisect. So the whole thing about bisecting has to do with whether the midpoints are shared for the diagonals, okay?
Yes, sir.
Yeah. And then 90 degrees has to do with that gradient of the diagonals having a product that gives you -1. That's how you check if they are perpendicular. Okay. So this one, is PQR a rhombus? No. Why? Diagonals do not bisect, at 90. They are perpendicular, but it's just that they don't bisect. So therefore we can't say it's a rhombus. Okay. Then 1.4, this last question, that I guess that will wrap up analytical for now. If T is the midpoint of PS, now we go to PS. Where's PS? Here's PS. Midpoint T. If T is the midpoint of P, determine the equation of the line which is perpendicular to who? To PS and passes through who? Through T. Perpendicular to who? To PS and passes through who? Passes through T. T is the midpoint. So if T is the midpoint, and apparently this line that is perpendicular passes through the midpoint, they want us to determine the what? The equation of which line? The line which is what? Perpendicular. Perpendicular to who? To PS.
Yes, sir.
Yeah. So practically, if I was to draw a sketch of this thing, it would be something like this. Like that. So if T is here, it's the midpoint, then you'd have a line which is perpendicular to
Yes, sir.
PS. Remember, S you already know is 2 and -3, and P you already know is -6 and 1. So when you want the equation of this perpendicular, we call this thing actually a perpendicular bisector. Okay, a line segment that cuts another line at 90 degrees at the midpoint. So we call this a perpendicular bisector. So what are we going to first do here? We want the equation of the line. Yeah, it seems like equation questions are coming left, right, and center.
I think so. We have to first find the gradient of the perpendicular line.
Which line? Which line specifically?
The T line, which is passing through P and S. No, which is passing through P.
Okay. So to get that gradient of this line, what do we need to first get? What gradient do we need to first get? So we can find the gradient of PS, right?
Yes.
Yeah, together with its midpoint. Because when we find the gradient of PS, then we know that we can find the gradient of this line T. Okay. Yeah, so two things, the gradient of PS and the midpoint of PS. That's what we need. So to calculate the gradient, okay, let's go. You can lead me there. Gradient of PS.
Gradient of PS, which is from earlier calculations, it was 1 or -1/2.
Oh yeah, gradient of PS -1/2. That's 100% correct. Yes. So then the gradient of T, gradient of line
is 2.
is gonna be
2.
2. Thank you very much. Oh, nice, man. I like it. So you know that concept of flip the fraction, change the sign. So -1/2 becomes 2/1, but then the sign changes from negative to positive. So that's why we say 2. Okay.
Yes, sir.
Yeah. Okay. Then we have the gradient sorted.
Then we use the coordinates for the midpoint of T.
Okay, so we need those midpoint of T. So
The coordinate of T is -2 and -1.
-2 and -1. Okay, let's just check if it really is by actually finding the midpoint. So x coordinate of P, -6, plus x coordinate of S, that's 2/2. Then y coordinate of P, that's 1, plus minus y coordinate of S, that's -3/2. If we substitute, we get -4/2, and we get -2/2. Is this correct?
Yes, it's correct.
So we get an answer of -2 and -1.
1.
That's t.
Yes.
So now we have a point. You can find the equation of the line. So let's use let's use this formula of yours, and then we'll also use the other one, just for the recognition of what we got from Shem.
Then it's gonna be y is equal to -1. Like okay, y is equal to -1 in a bracket -1, which is -1 and -1 is going to be +1.
Okay, y plus 1, yes.
Then it's going to be 2x. Oh, it's going to be 2. No, don't write. Yeah, it's x. Then it's going to be minus, which is minus, and -2 is going to be +2.
Okay, x plus 2.
Then it's going to be y plus 1 is equal to 2x plus 4.
Yebo.
Then the equation is going to be y is equal to 2x plus 3.
Okay. Good job. Let's just quickly use that C's method there, plus C, -2 and -1. You would check x is equal to y is equal to -1, 2 into -2 plus C. -1 is equal to -4 plus C. C is equal to 3. Y is equal to 2x plus 3. So that's an equation there. Okay, good job. Good. All right. I think we got that equation sorted. Awesome. So yeah, that was June paper and that was November paper respectively for analytical geometry. And yeah, that looked pretty sweet and awesome and beautiful.
This is actually what I wanted to ask, because I do not quite understand trigonometry.
Yeah, we are going to conclude with it for this session. Okay.
Yes.
Yeah, we are going to conclude on it because I thought let me do analytical and Trig in one video, and then what I'm going to do, I will upload this onto my YouTube channel so that if people want to rewatch it and stuff, they can do so at their own time. Yeah, very long videos, but I guess if you want meat, you get meat. If you want chicken feet, you get chicken feet.
What's the channel say? Like the name?
It's also called Maths is the Game. The link to the channel is in my bio.
Okay. Oh,
yeah, the link is there. I've attached it onto my homepage. The link. It's Maths is the Game 527. Yeah. So there in the following right angle, the triangle RST, we are told angle T is 90. Here it is 90. You can see most. Angle S is theta. Here it is. And then angle R silent. Write down 3.111, the ratio of cos theta. So we all know SOHCAHTOA, eh?
Yes, sir.
Dunia.
Oh, yes. Oh, I know.
Yeah, soccer.
Yes.
Yeah, soccer. We are currently watching Soccer World Cup. Eh? Yeah.
Yes.
Yo,
Yeah, soccer.
hi.
Yeah.
And
So
then
yeah. So ka. You see that feeling that you had when you were watching the national team lose very sorely against
Mexico.
yeah. You see that feeling? It's the same feeling I get when I'm marking learners' scripts.
Yeah.
Don't say that.
Yeah, but then the thing is that thing it what makes that thing is the way people choose to play the game in the field. You can coach them all you want. You can you can coach them all you want. If they want to show you flames, they'll show you flames to the disappointment of the nation. So
Yeah.
yeah, it's one of those things, man. It's very painful. Yeah, it's very painful. Anyways, so what is the ratio, guys, of cos theta if we are looking at this right angle triangle? So we know the sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So cos theta, we have ST, TR, and RS. So we need to write the ratio in terms of those signs. What is the ratio of cos theta?
Adjacent of hypotenuse. So adjacent is RT.
Adjacent is?
Adjacent is. Isn't it RT?
Okay, you see, when the adjacent thing is coming back. What did we say earlier on about the word adjacent? Adjacent means next to.
Next to.
So if you look at this theta, this is the theta they're talking about, this angle. Which side is next to this angle? Asenat?
ST.
Yeah, Asenat, it's ST. Now, I know some people get tempted to say it's SR. Yes, you are right. SR is next to the angle theta, but this side is not called the adjacent side. It's called the
Hypotenuse.
Why do we call it the hypotenuse? What distinguishes the hypotenuse from ST? Why are you
Because
not? Why are you so? Why are you so sure it's the hypotenuse?
Hypotenuse is the longest side in the triangle, and it is made by two opposites. If you multiply the square roots of two opposite sides, will give the number a hypotenuse.
Or if you by the way, if you add it's the sum of the square of the other two sides, which will give you the hypotenuse.
Sides.
The sum means yeah. But more specifically, you see this box here, it stands for what?
Yes.
What does it stand for, this box?
Right angle triangle.
It's right angle, right? 90 degrees.
Right
Yeah,
angle.
so this 90 degrees is always opposite the hypotenuse, okay? Yeah, so that's why when we talk about adjacent side, we dismiss the side because it's the one opposite 90, and we look at the other side next to, which is ST. So the adjacent side to angle theta is ST, okay?
Yes, sir.
Yeah. Then the hypotenuse, because you said cos is adjacent over hypotenuse. Which one is the hypotenuse side?
SR.
Thank you, SR. So please, guys, cos theta is simply ST over SR. Okay, any questions? Ka adjacent ST over hypotenuse SR. Any questions?
No, son. I don't have any.
Okay, so please, guys, understand that one. Look at 3.1, the ratio of cot 90 minus theta. Cot 90 minus theta. You guys saw theta. But where is 90 minus theta? Do we have 90 minus theta in the triangle?
Yes.
If you say yes, where is it? Okay, we don't have 90 minus theta. Can we find it? 90 minus theta. Can we
Can't
find
find
90?
it, Jonas.
You can't find it. Senior, can you find it?
No, I don't think so, sir.
Okay, yes we can. Look at 90, look at theta, this angle that is missing. If we say angle R plus 90 plus theta is equal to 180 degrees, reason, sum of angles in triangle. What is angle R going to be equal to?
90
180.
minus theta.
90 minus theta. This guy said, I can't find 90 minus theta. So it's the third angle, this one. That's theta, that's 90, that's 90 minus theta. So more specifically, that's theta, that's 90, this is 90 minus theta. Are we following?
Yes.
Yeah.
Yes, sir.
So then you find it, you go and insert it in your right angle triangle so that you have more information. You have theta now, you have 90, you have 90 minus theta. This is S, this is R, this is T. Any questions?
No, sir.
Then what is cot 90 minus theta?
So it doesn't cot stand for 1 over 10.
Yes.
If it's 1 over 10, you just place upside down E ratios of 10.
Asenati's got some good things to say. So then what would be cot 90 minus theta, Asenat?
It would be adjacent over, adjacent over the opposite.
Very
And
good.
then
Adjacent over
bracket
opposite.
them.
Which is it? Which is what?
My adjacent
Here's 90
side is
minus.
ST.
You are looking at this now. You're not looking at
Or
this
looking
anymore.
at that.
You're looking at this one. What is the adjacent? What is the opposite side of this one?
It's ST.
ST over what?
Over
No,
RT,
no,
but
no,
aren't
sorry.
you
Sorry. You said adjacent over opposite. What am I saying now? Okay, so?
RT is the adjacent.
Yeah, very good. I'm sorry. Sorry, my bad.
Over
Over?
ST, the opposite. ST.
Okay, good job. Good job, Asanati. Okay, are we together, senior?
No, sir.
So, here's the thing, Junior. There is SOHCAHTOA, then there is this one.
Yes.
Sine theta as a, well, let me say cosec theta has what we call, all the basic trig ratios have what we call reciprocal trig ratios. Reciprocals, right?
Yes.
So the first reciprocal is cosec, which is actually the reciprocal of sine, 1 over sine. Then there is sec, which is 1 over cos. And then lastly, there is cot, which is 1 over tan. Now, in as much as you know that sine is opposite over hypotenuse, cos is hypotenuse over opposite. Sec is hypotenuse over adjacent. And then
Yes, yes.
cot is adjacent over opposite. So then that introduces us to another Chosha Kao. The SOHCAHTOA which is your basic trig ratios. And then there is Chosha Kao, which is your reciprocal.
Yes, sir.
So remember, these are just ways of remembering. Otherwise, it's good when you just know the trig ratios and the reciprocals. Okay, so that's why Asenati was confidently able to say that cot is actually going to be 1 over tan. And then she said, when she explained, don't we just write the reverse or flip? If tan we know is opposite over adjacent, that means cot is simply going to be adjacent over opposite.
Yes, sir.
Yeah. So that's how you take care of that.
Now I hear you now.
Okay. Are you sure you hear us?
Yes, sir. I'm sure.
Okay. Yeah. So that's why cot 90 minus theta is, you need to then think adjacent over opposite. Okay. Yeah. Then the next question says the size of theta. If TR is to SR. Now, where's TR? This is TR. Where's SR? There is SR. They are saying if the ratio of TR is to SR is equal to 1 is to 2. 1 TR is to SR is to 2. They want the size of who? Of theta. So what do you guys think? So I've got 1 and 2. So that means this is my opposite, that is my hypotenuse for sine of theta. Theta will be equal to
1.5.
Now, guys, this is a special angle.
Oh.
Calculator here will be used nicely.
Sir, can I come back? I want to fetch my maths book real fast.
Okay. Okay. So you've got this one down, Miss RC.
Yes. The answer is theta is supposed to be equal to 30.
Exactly.
Try a calculator.
If I calculate. How did you do it when you put it in the calculator, Miss?
I press shift, then press sign, then it shows me a sign -1, then it shows bracket always, then 1 over 2.
So whenever you want to express this decimal as an angle, you take shift off that particular trig ratio on the other side. It's called arc sine. So the arc sine of half. Okay, so you press shift and sign, and then it will appear this thing, and then you can put half in the brackets, and when you actually get it, you get 30 degrees. Or because we know 1/2 is a special angle. Okay. Yeah. Yeah. So those special angle triangles, they help us out there. We can see 1/2 is the ratio of one of the special angle triangles. One of the ratios of this special angle triangle, 30/60. So if you go there to 30, opposite over hypotenuse. Sine 30 is opposite over hypotenuse. That's why theta is 30 degrees.
Oh, okay. So sometimes don't need to calculate them.
Yeah, especially for these. But you also, if you know your special angles well, then yeah, your special angles though, you know. Remember you have your 30/60 and you also have your 45/45. Yeah. So if you know these two special angle triangles, they can help you a lot, okay, with your calculations. No problem. Okay. Junior,
Yes, sir.
are you back? Your book? You good?
Yes.
Okay. So did you see or did you also listen to the explanation here of why we have theta is equals 30 degrees?
No, sir, I didn't quite hear.
No problem. We'll explain it for you. So here, remember they said they want us to write down the size of theta if TR, where's TR? Here's TR is to SR. Remember, this is a ratio, okay?
Yes, sir.
And the ratio can be written as a fraction as well. Yeah. Because the word ratio itself is the root word for the word rational. And rational number is a number that can be written as a fraction. Okay. Yeah. Where the numerator and the denominator are integers.
Yes, sir.
Yeah. So 1:2 is the same thing as 1/2 or 1/2.
Yes, sir. Okay.
So what we do then is we take the inverse of the trig ratio, evaluate it with the ratio 1/2, you will get the angle. To select this, you press shift sign, and you put the half in brackets. You should be able to get the angle.
Shift sign. Okay, I got it.
Yeah. So you can only do that when the trig ratio is isolated, right? And there's no coefficient of the actual trig ratio. Then you can take shift of whatever trig ratio you have on the left, on the other side.
Yes, sir.
Okay. Let's move on now here to 3.2. So for theta, if theta is an element of 0 to 90 degrees in the following equations, solve for theta if theta is an element of 0 to 90 degrees in the following equations. 3.2.1. Cos 3 theta is equal to 0.6. Okay. Do we know how to do these, yes?
Then try. Nombo seems like she can, or he or she can. In the comment section, there's someone that thinks that she can or he can do it.
Yeah, my question is, can you?
Yeah, I can try.
You can try. Okay, just hold on a second, silly.
Sir.
No.
No, sir.
Yes.
It's not Nomvu, it's Pagamile here.
It's Pagamile.
Hey, you remember me?
No, I don't remember you. I don't remember anyone.
Sir, I used to come with an account of Kambula.
My goodness, why do you have so many accounts?
You remember me now?
Yeah, I do remember you. You used someone else's account before you used Kambula. You used your mommy's account. Now you're using someone else's account. What's happening?
I think the problem is that my account cannot it is restricted like from TikTok.
Oh, okay. All right. Oh, no, I hear you. I hear you.
Mm.
But anyways, Kambula, we're shooting to go and sleep. We want to finish off
You
this.
are busy. You are busy with trigonometry.
Yeah, we're busy with trigonometry, so we just want to mobilize the masses there. 3.2.1 cos 3 theta is equal to 0.6. You said you can, so let's
So sir,
get that. Let's get.
you must get the theta isolated.
Okay, I'm listening. How? What do we do? First step.
So if ever we need to get the theta isolated, we must divide by cos 3.
Divide by cos 3. I'm listening.
Then after we divide by cos 3, I think we're going to get our theta.
Divide by cos 3.
Yes, do it, sir. I'll show you how.
I've written down cos 3 theta is equal to 0.6. What's the next step?
You have written that cos 3 is equals to cos 3 is equals to 0.6. Divide by cos or divide by cos 3. Divide it.
Divided by cos 3.
Yes, so that we can get theta isolated.
Okay. I'm kind of not agreeing with that. That's why I'm not doing it.
Or maybe wait. Maybe that 0.3 it says cos divided by 0. What? Wait. Let me figure it out. Wait, cos 3. Let me go and get my calculator and the pen and the paper.
Okay, no, I'm gonna give you a chance just now. Asenati says, "Can I help?" Asenati, yeah.
Yes.
So like we can just transpose. We can take the cos theta over to that 0.6. Then like we use the calculator thing. We press shift then cos. Then we'll 0.6 will give us the answer of 53,13. I used to choose the small points.
Okay. So you're saying then this 0.6, all of it. What do we get rounded off to 2 decimal places? Because it does say here, doesn't say anything about rounding off, but we know that if there's nothing here, we revert back to the instruction in the front cover page, and they say round off answer. Yeah, you may round off to 2 decimal places.
I first did the answer with the cos to -1 with the 0.6 in the brackets, then got the answer. It was 63,13 divided by 3. Then theta was equal to 17,71.
17,71. Okay.
Yes.
Yeah. So the initial value that you got, the inverse of cos or arc cos of 0.6, in your calculator, does it show many numbers after the comma, or does it actually itself terminate at a certain decimal place?
Wait, I'm gonna check.
Just check with arc cos of 0.6. What do you get?
Is just a equation.
Sorry?
It's 53,130,10235.
So that means it's a non-recurring and non-terminating decimal then.
Yes, sir.
Yeah. Then that whole entire value, that's the one you need to divide by 3. And then you only round off here at the end. Okay, the whole point is you must round off. Yeah. So want to avoid rounding off twice, round off at the end. So does 2 decimal places for the final answer get you 17.71 degrees still?
Yes, sir. It still gets 17.71003412. Let me go
Yes.
like shift to 2 decimal places. It gets me now.
Okay. You finally got it. So 0.6 in brackets. Okay, that's what you get initially. You divide all of that by 3. Yeah, you get 17.71. Yeah.
Oh, it can be wrong.
Yeah. So 17.71 degrees. That's fine. Yeah. So yeah, please guys, for you grade 10s, take note that yeah, if you have a trig ratio with a angle with its coefficient, you don't divide by cos. No, you take the arc of cos on the other side for the given numerical value. What is the point of taking the arc of cos on the other side? It's so that you can convert the decimal number into an angle. That's the whole point. Shift cos is designed to change a numerical value into an angle in degrees, right? So that's what you do. So there's a difference between the 0.6 as you see it with the angle. So that's why we take shift cos on the other side, but only when the trig ratio is isolated with no personal coefficient. But you take the inverse of cos on the other side, and it's fine if you isolate the coefficient of the angle alone so that you divide later on by 3. So that's important, because if you do it any other way, your answer could be different and may not reflect what is. Okay, hope that's clear for all. Then the next one, 3.2.23 tan of theta plus 15 degrees in brackets equal to 2.9. JR.
I think so. This is. Sir.
Yeah.
Yeah, I think this is where we have to divide the.
Divide by?
You have to divide by 3 tan.
Okay, so once again, we divide by what?
By 3.
By 3, not 3 tan.
Oh, you have to isolate them to the. Okay,
yeah. So this is the whole thing that I'm trying to hammer in here.
Okay.
Even with you, that we cannot divide by the trig ratio. We don't divide by the trig ratio, guys.
Okay.
Yeah. There's something I also want to clarify. This here, I think some of you think that 1 over tan is the same thing as the arc of tan. No, it's not, guys. This is not the same thing. So when you're saying you are dividing by, we don't divide the trig ratio by tan, okay? So the
Okay.
whole point here is to actually, once the trig ratio, so we divide by 3, of course, because we want to isolate the trig ratio. So 2,9 divided by 3, right?
Yes.
Because we divide both sides by 3.
Yes.
So that 2,9 divided by 3, you will get 29 over 30, right?
Yes.
Yeah. You isolate the what? The trig ratio. So here we can say that the trig ratio is now officially isolated.
Isolated.
Then we don't divide by tan, but we take the arc of tan
Tan.
on the other side, which is very important.
Mm.
Okay. Then
Yes.
you leave the theta plus 15 degrees on the
Along.
left-hand side.
Mm.
We evaluate this with arc of tan, then we transpose the 15. So
Okay.
anything that's related to the angle, we have to leave on its own whilst taking the trig ratio's inverse on the other side, arc of whatever the trig ratio is on the other side. Because the point of doing this, the arc of tan, is to convert a numerical value into an angle. Because you can't subtract this 15 degrees from a numerical value. You must subtract the 15 degrees from another angle. But you can only form another angle by arc of the trig ratio. You see? Yeah. For instance, at this stage, I can't take 15 and I can't take an angle in degrees and subtract 2,9, which is a numerical value. It makes no sense. You can't transpose the 15 at this stage, not at all. So you isolate the trig ratio, right, by first dividing by its coefficient. This is a numerical value, it's not an angle, right? Still, numerical value, not an angle. Still, numerical value. You take the arc of tan, now you convert this into an angle, right? So this here, you say shift tan, then you put in brackets 29 over 30. You close them brackets. That value is an angle, this one. So tan inverse of 29 over 30, you obviously going to subtract that with 15 degrees because it's an angle. So that minus the angle, this is an angle that you get, which is 44,02897. Then I want to round off, obviously. At the end, I subtract the 15, you get 29,03. 29,03 degrees if you round off to 2 decimal places. That is theta. Okay, I don't know if there's any questions, concerns, queries, comments, anything.
No, sir.
All I know is that marks in the bank, buddy boy. Marks in the bank. I don't know about you. Me, I don't want to be losing marks unnecessarily because of silly things like dividing by the trig ratio, all those things. Yeah. So are there any questions, any comments? Nothing? Nothing.
No,
We good.
I have nothing by my side.
Hmm?
I have nothing by my side.
Okay. So senior, are we at least getting the trig a little bit? There's a little bit of light there.
Yes, sir, it's coming.
I am sure Sneha is getting it.
You sure what, Arsenal?
I'm sure the senior is getting it.
Haha, I'm sure the senior is getting it. Yo, look at that. My goodness. Okay. Senior is getting a validation there. In which quadrant will theta lie in each of the following? 3.3.1. Sine is positive and tan is greater than 0. tan is less than 0? Which quadrant? So we know all students take cocaine, right?
I don't know.
Huh?
All students take cocaine.
Yeah, all of them.
Which quadrant?
Have you seen it,
Oh.
Asenat?
I have seen it, so but like, hey,
Yeah, all of them. They take it. All students take coffee at this time of the night. Yeah, all students need to take care. Yeah, need to take care of yourselves. All students take care. So if we come here, what does this mean? Sine theta is greater than 0. What does it mean?
it's positive.
It means sine is positive. Then what does this mean? Tan theta is less than 0.
Tan's negative.
Okay, are we all registering this?
Yes, sir.
Okay, now which quadrants reflect sine being positive? Which quadrant?
The first one. Or the first and the second.
First, second, I tick. Then let's go here, tan less than 0. Which quadrants reflect tan being negative?
In
Third one.
In the
The third one.
no, tan is positive in the third quadrant. We're saying where is tan negative?
In the first one.
In the first one, tan is positive as well.
Negative in the second one and the third one and the fourth one.
Second and fourth. You see?
Yeah.
So where are we overlapping?
In the second one.
So that's why we would say the answer is second quadrant. If they ask us, in which quadrant will theta lie in each of the following? It's going to lie where the ticks are overlapping. Second quadrant. That's the answer. Yeah. Theta lies in the second quadrant, if you want to write it fully. But second quadrant should suffice. Let's come here now. What does this mean? Cos theta greater than 0?
it's positive.
Who's
Positive.
Who's positive?
The cos.
Cos. Okay, then here, theta is an element of 90 to 360. What quadrants is 90 to 360 covering?
From the second quadrant to the fourth quadrant.
Okay, so let's come here and tick. Firstly, cos is positive. Which quadrant?
Cos is positive at the fourth quadrant.
Fourth?
And first.
Fourth and first. Okay, then next, 90 to 360.
From second quadrant.
Second, third,
Fourth.
fourth. Which quadrant overlaps?
The fourth.
Quadrant.
So we would say, where does the answer lie? Quadrant?
4.
That's where theta lies. Theta lies in. Theta lies in. We good?
Yes, sir.
Okay, the next one. In which quadrant negative sine theta is equal to negative theta? Which quadrant?
The third quadrant. I think.
Okay. Negative sine theta. What does negative sine theta mean?
It's less than 0.
Okay, and what does negative cos theta mean?
Cos theta.
It's also less than 0.
So which quadrants are those?
So like quadrant 2 sine is positive and quadrant 4 cos is positive. So quadrant 3 because they're both negative there.
They are both negative here.
Yes, sir.
Okay, quadrant 3. Do we see why, guys? Do we see, guys, that? Negative sine theta is equal to negative cos theta. Where are we talking here? Third quadrant. Here, only tan is positive, but sine is negative, cos is also negative in the third quadrant.
Okay.
Okay. Yeah. Right, let's look at this one. If tan theta is equal to 2 over 3 and theta lies between 180 and 360, determined by means of a sketch and without the use of a calculator, the value of. Okay, you guys got excited with this problem. What's happening?
That's not to say
We're
nothing.
not excited. We are
What
just.
do you mean you're not excited?
Problem now, I'm not excited.
Okay, why are you not excited, Asenati? These are like some of the most exciting
Easiest.
problems. Yeah, and easiest. Yeah.
I first explain self because
Let's start here. Tan theta is equal to 2 over 3. Tan is isolated, which is good. And according to 2 over 3, is this number a positive or a negative number? It is a?
both positive.
So that means tan is positive. Let's start there. Okay. 2. The 2 over 3. What is the definition of tan according to Zokato? Numerator
Opposite.
and then over
A.
okay. Opposite over adjacent. So that means opposite over adjacent. 2 will be our opposite side. 3 will be our adjacent side. That's the second piece of information. Are you guys satisfied with the piece of information that we got?
Yes.
Yeah, 2 things we get from the trig ratio itself. First goal is to make sure we isolate the trig ratio. If you are given the trig ratio and it's not isolated, your first goal is to isolate the trig ratio and then read 1, what is the condition of tan? 2, according to its ratio, what are the respective sides that are represented by the ratio? We good?
Yes.
Yes.
Okay. 2, the interval. Okay, sometimes we have an interval, sometimes they will have a trig ratio that's either positive or negative. But here we have an interval. 180, theta is greater than or equal to 180, but less than or equal to 360. Do you know which quadrants these are, 180 to 360? What quadrant?
It's going to be 100. It's going to be third and fourth quadrant.
Okay, third and fourth.
Fourth
So
quadrant.
let's play the game now of quadrant identification from 2 things. Firstly, the fact that tan is positive. Secondly, the fact that we have an interval 180 to 360. So let's take, where is tan positive?
On the first quadrant.
First and which quadrant?
And the third. Oh, third is yes.
First and third. Yes, according to Sokatoa, first and third. Very good.
Yeah.
All students take care. Then 180 to 360, which quadrant?
Fourth, third and fourth.
Third and
Fourth.
where is the overlap?
On the third quadrant.
So then we go, guys, and we draw. How difficult is this, guys? Third quadrant, for third quadrant. You draw your terminal arm. You complete your right angle triangle. You write R, you write Y, and you write X. You put theta there. Okay, that is your reference angle. Then, of course, you have your standard angle, okay, which is coming all the way from 0 all the way to the third quadrant, okay? But you have your theta angle, which is basically an acute angle. Then you fill in the rest of the diagram. You know that the third angle is always going to be 90 minus theta. So you have 90, you have theta, you have 90 minus theta. So you fill in all your sides, all angles. Why do you fill in the angles as well? Because in the event that they ask you about 90 minus theta, you can have that already in your diagram. 90 minus theta, theta, and 90. Fill in all the sides. Okay, according to the definition you had here, tan, you said, is opposite over adjacent, 2 over 3, but that's for theta. So according to theta, 2 is your opposite side. 2 over who? Over 3. But we're going to put the x and say it's negative 3, the y is negative 3. So why did we have a positive 2 over 3? It's because the negative divided by negative gives you back the positive. Okay, so y is negative 2. In the third quadrant, your y value here on the y-axis is a negative value. X is negative 3 because your x values in the x-axis are negative. Now, what don't we have here? We don't have
hypotenuse.
Yeah, we don't have the hypotenuse. So we use Pythagoras to find what? The missing side. R squared is equal to x squared plus y squared. Our R is what we are looking for. X, negative 3 squared. Y, negative 2 squared. We get 9 plus 4. 9 plus who? 9 plus 4. We take the square root on both sides. We put plus minus when we put the square root. So it's square root of 13 plus minus R is equal to the square root of 13. So that means R is always positive. So that's why we save it as R is equal to square root of 13. Okay. Then we go and complete the diagram. Root 13. This is a full complete diagram. Now you can answer the questions that relate to that diagram. They said the first one is calculate the value of cos theta. So let's calculate the value of who? Cos theta. We go to the diagram. Where's theta? There is theta. What is cos? According to adjacent is what? What's the value of the adjacent side?
Negative 3.
Do you all see that, guys?
Yes.
Negative 3 over hypotenuse. Hypotenuse is?
Square root of 13.
Okay, square root of 13. And you leave your answer right there, like that, no problem for now. That's 3.4.1. 3.4.2, they want the value of sec squared theta minus 1 over tan squared theta. But since it's squared, guys, I'm going to take the squared outside and write tan theta as a ratio. Then we are going to play substitution game. Okay, we go to the diagram. What is the value of sec according to the diagram?
Sec isn't the reciprocal of cos.
Very good. It is. Sec is the reciprocal of cos. So if cos is adjacent over hypotenuse, what is this one?
It's hypotenuse over adjacent.
Thank you, hypotenuse over adjacent. So we go to theta and we say hypotenuse over adjacent. So that's square root 13 over negative 3. You square it minus half. What's tan? According to this diagram.
O over A.
Yes,
Which is
what?
negative 2 over negative 3.
Say that again. It is?
Negative 2 over 3, negative 3.
Do we agree, guys? Do we agree?
Yes, we agree.
Yes, we agree. Why is the senior so quiet, man?
Who?
Senior, why is he quiet?
I don't know. Maybe he's sleeping. Maybe he passed out.
Senior, we want you back from the table.
Senior, you're wanted back. Okay, there we have it. So square root of 13 squared is 13.
Yeah.
Negative 3 squared, the negative sign becomes positive. 3 squared is 9. That's 4 over 9. And let's not forget 13 over 9 minus 4 over 18. Equivalent fractions. 26 over 18 minus 4 over 18. That gives you 22 over 18, which when you simplify, you will get a simpler answer of 11 over 9.
Yes.
Yeah, so this is how you do these Pythagoras type questions, guys. There's nothing too... Yeah. Any questions?
Nope. I don't think there's any questions.
Yeah. Yeah. Now, my beautiful people, I'm going to have to love and leave you because I have an early morning.
Sir,
Yes.
you remember you promised us to send the question papers?
Yeah, but that was only if you had established the group and sent me a message that the group was established, so I could send you the question papers, remember?
Yes, sir.
Yeah. So I think we're living in a realm of unfulfilled promises on either end. Eh?
No.
Guys, make a group, people.
I'm still trying to create a
People
group
must make a
here.
group.
Sorry, Asinat?
The people must make a group. You promised them maths question papers must.
The people, the maths, the question papers will only come if the people will make a group. Then I can forward question papers. But I won't be able to forward question papers if there's no group.
Yes, I agree. You said there must be 20 people, so I'm still waiting for that.
No, it's fine. It's fine. It doesn't have. We don't have to push it that far. My goodness, the time will come, and then you won't have enough numbers. Just it's fine. Just let me know if you have started the group, and then you can
Yes,
summon.
especially paper 2 before we write. I say you are.
Yeah.
When are you going to do grade 10 again? Paper 2.
Tomorrow. I mean, well, today, later on in the evening.
What time?
9 o'clock. 9.
9.
Yeah.
Okay, I'll be here. Thank you, sir. I'll also give you the name of the group, and also you can
Yeah, sure.
Oh, please
Sure
add
thing.
me, guys.
you can you can
Yeah, just DM him, like, yeah, because not
yes,
like that other time when someone actually wanted to publicly declare have her phone number for everyone to hear. Hey, dangerous thing.
it was like 073.
Hey, please, guys.
Yes.
Yeah.
Okay, sir. Thank you.
No problem, man. No problem. Where am I from? I'm from the Eastern Cape, your mother's boyfriend. Who's like this guy, your mother's boyfriend? What in the world, man? Yeah, guys, your names. I am TikTok. I your mother's boyfriend. What in the world, man?
So you live in Eastern Cape?
Yeah, these people. Yeah, man. I'm Xhosa, man. I'm ex-Hosa.
Hey, Bo.
Neighbor. No, I thought you were here in Free
Wait.
State.
You thought I was where?
In Free State.
Yo, Free State for what? I'm not from the Free State, my
Hey,
guy.
Bo, sir.
Yo.
Where are you from, Eastern Cape? Maybe.
Asinati, let's not get there. You see, now you are getting too
Hey,
personal.
Bo.
It's enough to know I'm from the Eastern Cape somewhere,
Okay, it's fine,
Maybe I'm
sir.
from
Okay.
Bizana, maybe I'm from, could be from anywhere. Mtata, you know.
Yeah, that's different
Yeah,
from me.
maybe I'm from Lusikisiki. You never know, eh? Port
So,
St.
yeah, you're
John.
just naming places.
Yeah, I'm naming places because these are all Eastern Cape places. East London,
Hi, man. The smart people, such like people who can analyze things better, like you are from Free State. Mm-mm. I haven't seen a causer who can no in my entire life. Even in the national awards, we always win as Free State. Your Free State is so it's nice. Yeah.
People that analyze, okay, maybe we are breaking borders, breaking boundaries.
Maybe one of your parents are from Free State.
No, not even, my guy, not even.
Your grandfather, maybe you don't know.
Maybe. My grandfather. No, actually, I found out that in my ancestry, I also have Indian heritage. So I don't know about, grandfather being from Free State, but yeah.
Serious.
Yeah, apparently I have Indian heritage, man. It was quite a shock for me. So one of those nice things to discover, It's like interesting. But yeah, guys, I'm ex-Hosa, so yeah.
Yeah. So let me create the group, then you send the question paper tomorrow. Then I need to practice. We are writing paper 2 and I don't know anything. Bye bye, guys.
You are such a liar, you don't know anything. By the way, this guy, the one, like, when was it? I think it was a few days ago. This guy was in my live and he was answering geometry like it's nothing.
So you understand geometry. I'm not good in trigonometry, especially this thing of quadrants and what you really helped me to get today. Like I was like, okay, this is how we do it. Okay, this is
Yeah.
how.
Okay, then I'm glad we could.
Yes,
Yeah,
please
because
again tomorrow do trigonometry.
yeah. I'll be back tomorrow.
Yeah.
We'll finish off the rest of these trigonometry questions because there's this angle of elevation and depression stuff here as well. You don't want to be depressed.
Hey, sir, please, it's about
Yeah.
to go down on the 20th. Well, I think it's 22nd. Yeah.
Yeah. Can't you? Who's this? Asenat, when are you writing? When are you writing already? Junior?
So, I am writing on the 17th. It's my last day, but I still got more time to study though. And I got a lot
Oh,
of question papers
17.
to do.
Oh, 17. And then Junior?
Another I was writing.
Means I'm writing on the 17.
Hey!
Part 2.
Hey, boy. Junior, can't you? Where are you springing from? Don't be specific. We just want a provincial representation.
KwaZulu-Natal.
Miss London.
Yo, KZN papers, guys. Hey, KZN people.
Yo, say you saw that one of grade 11 where they asked the letters of parabola of a building.
No, grade 11 papers was hectic.
Even the life science one, you.
Yeah. But that was a nice paper though. It was very sweet for them.
Said abantwana baya apply fanele ukuthi benze izinto zibe lula man.
Yeah, I hear you. But it was a good challenging paper though. That paper I will be using for many years to come. That one.
So, do you know somebody who are you also doing physics?
No. I don't do physics. I'm focusing on one niche, not many niches. Hey,
I say you. I thought you were also doing physical science.
No. I'm doing only maths. Maybe in the next few years I'll really do physics, but for now, man, I'm just enjoying the maths. It's nice doing maths here. So
physics. In the many years whereby I'll be done with school.
Yeah, pretty much. You'll be done with school by that time when I decide, but hey, let's do the
physics part.
Physics, yeah. Nah, unfortunately, buddy, unfortunately.
Yeah,
unfortunately. Yeah, unfortunately.
You think we're gonna be confused by changing your accent?
Confused by Abo. Confused by what now?
Unfortunately.
Confused by what now? Confused by what now? Confused by what now?
You're gonna be going home on the 30th of June if you keep doing like that.
You'll be Hi man, going home my foot. What is this now? Going home my foot. Just because I can use accents, it does not mean I'm going anywhere. It means I am versatile. I can, I can adapt under any condition, under any circumstance. Yeah. I'm ex-hoser, man. I'm ex-hoser. Ex-hoser, yeah, ex-hoser. I speak ex-hoser.
Xhosa, isiXhosa, yebo. What ex-hoser?
All right, guys. Well, yeah, I'll await the beautiful group, and then yeah, you guys we'll rock and ride it. But yeah, guys, till we meet again. Cheerio, toodles.
Tomorrow 7.
Yeah, cheerio, toodles. Yeah, sure.
Bye.
So guys, bye.
Bye, guys.
Bye.